So good morning, everyone. I welcome you all to this 2 days training on LEDIT and ESP PDK. I thank you for joining our session today. So I would like to first welcome our instructor, Marianne Mayer. She's the CEO of SoftMems LLC. She received her PhD degree from Caltech in the area of semiconductor device modeling in developing a new charge-based transistor model. She pursued her postdoctoral studies at the Swiss Center for Electronics and Microtechnology in Switzerland. Joining Tanner Research in 1992, she began the simulation and modeling group and launched Tanner's P-Spice analog circuit simulator product, the MEMS Pro Microsystems, and MCM Pro multi-chip module and packaging design tool suites. She moved to MEMSCAP in 1999 as an executive vice president and became the company's CTO in 2001. She founded SoftMems LLC in 2004 to address the need for co-design tools for systems incorporating MEMS sensors, electronics, and packaging. It gives me a great pleasure to welcome her to today's session. Thank you, Marianne, for joining us.
Sure, I'm a big CMC supporter.
So I'll just give you a brief introduction about what CMC does. What are all the areas that we cover? You could hear it from our CEO, Gord, here.
CMC is a not-for-profit organization that provides services mainly to university researchers across Canada. I like to group those into three parts: CAD, Fab, and Lab. In terms of CAD, we offer 52 different computer-aided design packages from 30 different vendors across Canada at a very, very low subscription price, and about 10,000 students use our services every year. In fabrication, we offer 20 different factories around the world. We manage the complete process, and we bundle designs together to reduce the costs for the researchers. And finally, we have Lab, where we develop technology platforms that can be used in labs across Canada, and they can be built anywhere and used as a basis for further research. CMC is important to Canada because it's a platform that rolls out and serves every university with anything remotely like an engineering or science program with services that would be much too difficult for them to put together themselves. CMC is distinctive in that we don't charge higher prices to one university than another or to one researcher than another. Every researcher coming into a university can immediately sign up and use our tools, our CAD, our fabrication facilities, and our labs. Research and development in microelectronics and nanodevices is critically important for pretty much every application area you can think of, whether it's agriculture or resources or advanced manufacturing or robotics or computation. We critically require skilled people who understand the requirements of microelectronics and nano-manufacturing. Here in Canada, there are a few areas that we have significant advantage, and those are the kinds of things that we want to really boost here at CMC. Photonics, quantum electronics, quantum communications, these are the kinds of things that we are focusing on now, while not leaving behind the core electronic resources that are required by every researcher.
I hope that gave you a brief introduction about what CMC does. The outline for the training: on day one, we would be covering the LEDIT. I'm sure Marianne would be speaking a lot more into it, so I'm not going to do it again here. And on day two, I know a couple of you are only joining for day one. So just to keep you informed, on day two, we would be talking exclusively about our electronic sensor platform and the PDK along with that. It would build upon the concepts that you have learned on day one. So these are the timings. We would be taking about 5 minutes break every hour or so, just so that you have some time to refresh yourself. And we have 2 lunch breaks. Now, I think most of you are connected to the software, but just to remind you, please check the box on Mentor to be able to connect to the license. And also ensure that you are connected to the CMC license services. So at any point, if you feel that you have got disconnected, please check if this is connected. If it's not, you need to re-log in into your CAD Connect. So through the AppGate icon. I think now there's a newer version of this AppGate icon. So you need to go back, log in here, and then you will see that you're connected to the CMC license services. I think that's all I had from my end, Marianne. So I give the floor to you now.
Okay, great. Thanks, Priya. So welcome everybody. So this class, day one, is intended for those who have no experience with TAN or L-edit. If you do have some experience, you may benefit from the class, but you may be a little bored with the beginning of what we're going to talk about. On each section, I'm going to give an overview of what we're going to cover. So those of you who do have some L-edit experience can decide if they want to do something else, answer email or so during that section. But as I said, we're going to start from the very beginning, and we assume no knowledge whatsoever of L-edit in this day one. And then, as Priya mentioned, day two, we'll use the concepts that we learned in day one, and we'll apply them to being able to utilize the design kit for the JFET process that was developed at 3IT and the PDK that was developed by CMC. All right, so these are the objectives. Okay, so I read the first ones. We're going to talk about layers and masks so that tomorrow when you take a look at the JFETs, the JFET PDK, the layers will be familiar with you. You'll learn how to draw and edit in this tool. L-edit is a bit different than some of the other drawing packages out there, specifically AutoCAD. So I'll talk about how to draw things, how to edit them, and then we'll talk about also the concept of cells and hierarchy. And as I said, this is really basic stuff. So those of you who already know how to do this in L-edit may join us for some of the later modules today. But this first couple of hours we'll cover this stuff so that you can, really start with a blank L-edit and know what to do. Okay, so first let's talk about the user interface and the toolbars. And so you can start L-edit in various ways, and hopefully Priya's got you all set up so that you can access the CAD path. There should be a desktop shortcut. You can also, all the files are located here under program files, soft MEMS, MEMS Pro, so you can start the L-edit from, right from that directory. You can also find it in your start menu. And if you have a TAN or file, which typically looks like this, it has a big L on it for L-edit, you can usually double click it and that will start up an L-edit. Another way to do, to open a file really quickly is if you have L-edit open, you can drag and drop a file into L-edit. Okay, so there's one thing that we'll learn in this class is there's about 10 ways to do anything. So a lot of what I'm going to do is show you one way to do something and then give you notes on how to do other ways of doing it. Sometimes I'll show you how to do things more than one way just because they're important to, and it's more convenient if you do know both ways. Okay, so L-edit is just like any other Windows program. L-edit actually does, there are some parts of soft MEMS and L-edit that run under Linux, but we're going to be looking at the version that runs on Windows today. And we also know that, L-edit, although it officially doesn't run on Macs, if you have a virtual machine on your Mac, you can usually get it to run there. So this is the interface that you will see in the Windows. So you'll have, like any other program, you've got a bunch of toolbars and menu bars. The center of the screen is usually a layout area, which is where you define your layout. We also have a little toolbar that, Priya, do you actually see where my mouse goes?
Yes.
Okay, great. We also have another toolbar, which will have additional functionality that we'll call up. And then there are at the bottom, there is what's called the status bar, which is a good place to look for any kind of messages about what's going on with the operations that you're doing. So your edit should look something like this. One of the things that occurs in edit is you can rearrange your screen and customize it so that it looks the way you want it to and is most efficient for you. And we'll learn how to do that. So your edit screen may look different than mine and different than this picture, depending upon how you have customized it. The other thing about edit, besides all the toolbars, is there are a lot of windows that you can either have them all present, or you can, stack them up like I have here, so you can see them all at once, or you can stack them so that they are, the windows are tabbed in some way. So it's up to you how you want to do that. But sometimes you can get a bit lost. But edit itself does have a place where you can make a layout, but then it also uses a text editor, for example. We'll see that tomorrow when we look at some of the code that Priya wrote for the JFETs. She actually uses the text window of edit to enter that code. We also have a number of navigators. Today we'll actually look at the library navigator that's going to allow you to look at the library of pre-designed edit information that is in the design kit. So a lot of navigators, a lot of different types of windows, and we'll learn about each of them today. But as I said, you will be able to move these windows around and also customize them. Okay, so we are going to go ahead and get started with edit, and we're going to look at this class as kind of like an onion. So we're going to look at some basics first, and then go on to more and more advanced stuff as the day goes on. So what we're going to do in the morning is we're going to work with some predefined files that I have already designed for you, or my team has, and then later we'll look at how do we create a file from scratch with nothing in it, and then work with design kits and libraries so that you can make your own designs. So if you're following along with me, I'd like you to use File Open to open an existing edit file. And in the Dropbox, we have provided a set of files that we'll use today. And one of them is called resin.tdb. And that is a file that I have loaded with some interesting layouts for you. And we're going to go ahead and open it. And edit files typically have an extension like this, .tdb, and that stands for Tanner Database. And so if you see TDB files, or people refer to TDB files, that's what they're talking about. And Priya, as I understand it, are you guys going to accept TDB files for your submissions for the JFET run?
Yes, but then we usually convert it to GDS before we send it to the fab.
You usually convert it to what?
GDS.
Right. So that's one thing that we're going to talk about today, is that Tanner database files are, the file that contains all of your edit information, and it contains a lot of information besides just your layout. But there's other formats, which one of them you probably have heard of is GDS too, and that is a format that has a lot less of the information about your design, but it has enough for the fabricator to work on it. So typically we suggest that you exchange TDB files until you're ready to have your final design written out. And then we'll talk about that today, or maybe tomorrow, how we create GDS2 files from the TDB file. So, but you will hear a lot about TDB, and as you're interacting with CMC, or maybe sharing some files amongst yourselves, you will most likely be emailing or sending TDB files. So I'm going to interactively go ahead and also follow along with myself. So I'm going to go ahead and open that resin.tdb file. There should be something called data for class in that Dropbox under day 1 edit training. So you can go ahead and do File Open and open that file. And it should look something like this. And at any time, if you are following along with me and you don't see what I have on the screen, just ask me, or if you can't, it's a little hard because we're remote like this. If you missed, the command that I did and I did it too fast, just tell me and I'll repeat it for you, okay? So does everyone who is following along, were they able to open that file?
I have a small question.
Sure.
So I see on my screen different LED versions, like LED photonics, LED MEMS. I don't see the LED MEMS Pro that you have opened. I don't know why it doesn't come on my screen. Is it a different, what's the way to open the MEMS Pro?
Okay, good question. There are different LEDs that I think that the CMC has, works with. And Priya, did they download MEMS Pro?
Yeah, I downloaded it.
Okay, so it should say MEMS LED in your start bar. So it should look like this. In the start bar, it should be, it should look like this. MEMS
Okay.
LED.
Yeah, I see that. Yeah.
MEMS LED, the 11, start that one. Yeah.
Okay.
MEMS, because we put the MEMS in it so that, people would recognize that this is the MEMS LED as opposed to the photonics or something else.
Okay, yeah, it's working. It's working now. Thanks.
Okay, and you might ask, what's the difference and why do we have different versions, right? Eventually, hopefully someday we will only have one version. We're working on that with Mentor, but we have put special commands and customizations into the MEMS LED that are specifically for doing certain types of layouts and things like that. And I guess we will most likely be teaching a class or so with, like, for example, for photonics people using that version. Okay. Any other questions? As I said, please do stop me because I can just help you out directly if for simple questions like this. Otherwise, if there's something else, Priya will be able to help you. I won't be able to monitor the chat myself, Priya, because it's hard for me. I have to switch back and forth. But if there's something in the chat that I need to be aware of, just give me a shout, okay?
Sure, and everybody seems to be able to open the file.
Excellent. Okay, great. Let's go back. Okay, so we've got our file there. Yeah, I'm going to try popping back and forth between the tool live. Let's see. There we go. Okay, so we open that up. Now, some of the things that you can do, if you noticed when I opened my file, I had a lot of toolbars and my screen was very, the area available to me to do layout was very small because I have all these toolbars open. And so one of the things that you can do is customize your environment by going into the view toolbars. And you can show or hide a toolbar by clicking the boxes next to them. And so there are these toolbars that appear at the top of the screen. As I mentioned, we saw that in the first interface, and those are listed here. And these are the most, some of the most important ones. You want to make sure that you have your drawing toolbar on, your editing toolbar, so that you can draw and edit. But some of the other toolbars we'll be using later, so that you may want to just have as few as possible, so you have more screen real estate. So, you don't have to customize your screen at this time, but later on, once you get used to the tool, you may want to turn off some of the toolbars. And then, as I mentioned, there are also a different set of tools and toolbars, and these are called docking views. And so instead of there being like a little ribbon of little tools up on, as we saw at the top, we actually have little windows that can be docked or undocked or viewed. And some of the ones that we will be using today are, we will have our library navigator pop up. We will also be doing design rule checking. And so that is a docking view. We also, our layer palette, which we use for drawing, is also a docking view. So at this time, you can go ahead if you like and do hide docked views. and that will make sure that none of the these windows are up on your screen and taking your screen real estate. But you can leave the toolbars on that you see above. Okay, any questions about the toolbars and docking views? As I said, I'll just show you briefly on the tool itself. Let's see. These here that I'm kind of going over, these are the regular toolbars. And so you, if you want to, I don't know if I can move this, this little interface, the Zoom interface. I'm just going to move down my edit here because it's interfering with the Zoom interface. If you go into view toolbars like I did, you can turn them on and off. And then the other one was the view docking views. These are all the different docking views, and I've hidden all my docking views, and later we'll be able to turn them on as we need to do DRC, or as we start working with libraries or things like that. Or, you know, we can, there's even a command line in edit. We won't cover the command line in this class, but a lot of the commands in edit are scripted, so you can just type them into the little command line if you need to do that, or if you want to do that. So let's go back to the PowerPoint. And so you can also make a toolbar visible by right-clicking the menu bar in edit and selecting that toolbar. So that's another convenient way to do to turn on your toolbars. The other thing that you can do is to customize your design environment. You can rearrange your toolbars by dragging on their right-hand side tab. So if you look very carefully at a toolbar, it has these little lines that are on their on the side. And that's actually on the left. So you can then just drag them around and move them. We'll do that in a minute. And the other thing that's very helpful is sometimes, you know, people look at these little icons. Sometimes they're obvious. I think the icon designers did a fabulous job. But if you are not sure what a icon does, if you hover lightly over it, it will tell you what its function is. So that's really helpful. So for example, if we go back into edit, you can see all my toolbars are really, you know, are really stacked here. So I can grab them right by their little left-hand corner there and just grab them and move them. And then this way they'll, you know, they'll take up less real estate, and I can, you know, I'll be able to get more screen real estate for drawing my design. And as I said, if you have a toolbar that's turned off, you can right click and just turn a toolbar on directly by right clicking in the toolbar area and turning on the one that you want. So that's a little shortcut. Okay. So now one of the things that we do for MEMS folks is that edit is unusual in the fact that it has a number of curved features, which we'll talk about later. Maybe not so important for JFET designers, but for MEMS designers, photonics designers, we need to often draw all angles and curves. And so one of the things that we want to make sure is that that capability is turned on. Sometimes it gets turned off by default, depending on how you've set up your edit. So I wanted to make sure that you would be able to learn how to turn it back on, because sometimes your toolbar may look like this. You have a, you know, the pointer tool, the polygon tools, but you don't see your curve tools. And you can turn them back on, and then you'll get the capability for drawing curves. And so you can right click on that drawing toolbar and make sure that the little checkbox is near the all angle and curves. And then you'll have them available to you. So I'll demo that right now. You can see my all angle and curves are turned on, and if they were not, you know, I could get them to be turned on by going down here. Hopefully you can see that on my screen. They're checked on. If I uncheck that box, I would remove them. So just make sure that yours are on if you want to draw curves. Edit tries to make everything neat and tidy, and then, you know, for those people who are doing transistors that are just squares, you know, they don't care about curves, so Edit doesn't clutter up your screen with them. But for us doing MEMS, we do curves all the time. You can also enable the curves by going into the setup menu, setup application, which we'll talk about later. Okay, so now one of the things that is in the new version of Edit, for those who have not used Edit in a while, you can automatically position all your toolbars and have Edit pack them for you. And the other thing that you can do in Edit is you can also select the button size that you want your buttons to see. And that's one of the things that we'll talk about, is for those people who have 4K screens, you know, let us know if you need some help optimizing how the Edit appears to you, because for some people with very large monitors, maybe the toolbars are too small to see, or maybe they're too big, you know, the buttons might be too big. So, you know, there's a lot of different types of screens out there. So, you know, Edit has tried to support as many as possible. But if you need us to help you customize your screen, we can do that during the break. But here's some general help that you can, you know, change your button size if it's too small on your big monitor. Because some people have laptops where everything's squished down, and other people have giant monitors with 4K, and so the buttons, you know, could be too big or too small. As I said, the 4K support has the button size. Okay, so that's about it for customizing your environment. So now you should be able to set up Edit so that it looks nice for you, and your screen is organized the way you would like it. So now we're ready to talk about, you know, actual design issues. So the first thing I'd like to talk about, and this is, you know, the first thing that really connects to what you're going to be doing tomorrow with the JFETs, is we need to talk about how Edit represents numbers and also the grids that Edit uses. And most people who, you know, start drawing with Edit just completely ignore this topic because they want to just draw things and get started. But the way that you set up your technology is really going to have a lot of implications for what happens to your design. And this actually does affect the way the JFET design kit was created. So the first thing I want you to do, if you're following along with me, is go to Setup Design, and that's in the Setup menu at the top. And then look at this first tab. It's called the Technology tab here. Okay, so this, when you go into Setup Design, you'll see a bunch of tabs. And the first one is called the Technology tab. And when we look at the design kit, you'll see that the design kit, say for example, for the JFET has a different name. This is the setup for the MUMPS technology, which a lot of you, you know, who use CMC products will be familiar with, is the MUMPS design kit. So typically it has the name of the technology and the version of that technology. So MUMPS has had many, many versions. I think this was from version 11. And then the next thing that gets defined is two things. One is the display units. And so this is important because Edit will be displaying a lot of numbers on the screen. And so what you display, the units that you display, you want to be able to quickly look at them and go, oh yeah, okay, that's 12 microns. So typically people set their display in microns for people doing you know, IC technologies, or in your case, the JFET and mostly MEMS. But some people do use LEdit for designing boards and other things where they may want to use mils or inches. And some people, design stuff where they are using millimeters in LEdit, but we've used microns. And so just leave that technology unit alone, and it's usually set in the design kit. And then the next thing that you want to set or be aware of is the database resolution. And you can see here that this database resolution is set over to 1/1000 microns. So what that means is that you cannot represent any numbers less than a nanometer. So this has implications for folks doing photonics, there, or some other types of devices. If you're doing any nanostructures, here, this setting will not allow you to do tenths of nanometers, because it's just going to be resolved into a unit that cannot be distinguished from a tenth of a nanometer to another tenth of a nanometer. So why does this happen? Well, behind the engine of LEdit, LEdit is actually not a floating point tool, and neither are most layout editors. They're actually working on a grid, and the resolution of the numbers are set by this database resolution. And you might wonder, why don't I just set this to a big number? Well, I mean, or actually a small number, the resolution to be finer. Well, that means that because you're working in a integer coordinate system instead of floating point, you would then not be able to resolve very, very large structures. So typically when we're doing integrated circuits or JFETs or MEMS, 1/1000 microns is good enough, because we're not going to make anything bigger than a couple of millimeters, and our resolution of 1 nanometer is good enough. But as I said, if you're doing photonics or you're doing nanotech, you may want more resolution. But just be clear on this, that when we look at some of the all angle routing that you might do with your JFETs, or all angle routing that you are doing, for other projects, that any of the numbers that are, off the grid are going to be just truncated to a nanometer. And this will have implications when we do the design rule checking, because LEdit will not be able to resolve, as I said, anything in the tenths of nanometers if our database resolution is set this way. So one of the things that you want to do when you start working with the design kit is make sure that your design has the same settings as the design kit. So Priya and the CMC team has set the resolution in the design kit, as we'll see tomorrow, to a nanometer. So make sure that your design is also set to a nanometer. So the first thing you do when you start a design is make sure that your settings of your individual project match the design kit. And we'll go over that tomorrow, because you can have unintended consequences if you don't do that, okay? And so the next thing I want you to do is go over to the grid tab, and you'll see that this is where we set a bunch of information that is related to the internal resolution, the internal units that we saw. So LEdit, excuse me, LEdit is a gridded system. So that means that, as I told you, we have these internal units, and then we have the grid points that are displayed to help you put your design on a grid. And so, for example, in the JFET process, we don't have anything that's really smaller than 5 microns or so. So you really want to work in, displaying, your information or your grid points in some multiple of microns. And you might even want to change the display grid, the minor display grid, to 5 if the smallest thing you're designing is 5. So in this case, we have a minor display grid of 1 micron and then a bigger display grid of 10. And so that means LEdit is going to put a bunch of dots on the screen to help you locate your features. And when you zoom out, you'll only see the major design grid. And then when you zoom back in, you'll be able to see at the micron level. And then the other thing that that we set here is that we can also set how the mouse behaves. So this is a good thing to do, especially if you're new to ELEDIT, is to create a snapping mouse. And if you choose the snapping option here, it means that your mouse will not let you touch any points on the screen that are not on that grid. And if you choose the smooth option, it means that ELEDIT will let you address any points in between the grid points. So there's pluses and minuses to this. If you are designing things that have a lot of circles and curved structures, by definition, they're not going to be on the grid. But for example, you might set their center to be on the grid. So depending upon how you're doing your design, you often want to put key reference points snapped to the grid, but sometimes you have to, in order to select objects or touch them, you have to unsnap and use the smooth option. But I typically keep my mouse snapping until I have to release it to address some all angle structures. And then the other thing to note is that the locator bar on the screen is going to display where you're pointing with your mouse. And I'll show you this in a minute. So it's going to show you that in that display in microns, because that was how we set it. And then it has the resolution of the database. As I showed you here, this is showing that we have 53 microns with 3 points of precision after, because we set our internal unit to 1/1000 or a nanometer. Okay, and then the last part of this screen, which is really, really important to know, let's see if I have a separate slide on it. Yeah, is the manufacturing grid. And the manufacturing grid is really important, especially the way that the PDK is set up for the JFET, is that all points on your design are going to be snapped to the manufacturing grid. So in this case, for the polymumps process, the manufacturing grid is set to 1/2 micron. So that means that when you write out your GDS file, there will be no coordinates that are like 0.51, 0.52, because even though your database resolution is set to a nanometer, the manufacturing grid was set to 0.5. And why does this happen? Because different mask makers want you to be on a grid when they go ahead and make your masks. And as I mentioned, if we have curved structures, those curved structures are going to be by definition off the grid. So before they are, before we write out the GDS2 file, or before we do a design rule check or anything like that, we're going to be snapping to that manufacturing grid. And so one of the things that ELEDIT has done sorry, my screen's going a little crazy here. Let's see. One of the things that they've added in ELEDIT to make things easier for you is that you can display your curves using the manufacturing grid, so you can see what they look like before they get written out to the GDS2. So this is really important to know and to understand the different grids in ELEDIT. So we have how our numbers are represented. We have the grids that appear on the screen. We have how our mouse can be snapping or to the grid points. And then we have the manufacturing grid. So all of these numbers are interrelated. And tomorrow, when we talk about the design kit, we'll go over how they're set for your design kit and what that means for how you do the design. Because sometimes we were even talking about this with Priya yesterday, that if you have a snapping mouse grid and she happened to have some points that were off grid, she had to remove the snap so she could address the points that were not on grid. And so I'll point this out, it's a lot to kind of think about in the beginning, but as we go on in the class, I'll explain to you more about the grid and how we're using it. And we'll talk many times about the manufacturing grid, but I just wanted to begin the class by helping you to understand, what's behind some of the things that happen as we, actually put polygons on the screen. A lot of the things that happen to those polygons are defined by this grid. So Priya, I think we promised, what, a 5-minute break every hour, is that right?
Yes.
Okay, so do we want to take a bit of a break for just 5 minutes or stretch your legs or?
I think we could take a 5-minute break.
Right, especially since grids is, you got to get your head around the grids, right?
Yes.
Okay, all right, so guys, we'll give you 5 minutes to just, take a little mental break, and we'll be back in 5.
Mary, I have a question
Sure.
about the manufacturing grid.
Sure.
If the grid size specified in the software is, say, bigger than the actual manufacturing grid, what could be the result? I mean, like if it's not equal, but it's like either like greater than the actual value or smaller than the actual value, do they have the same consequence?
Okay, but which grid, when you say, are you talking about the manufacturing grid of electrode or the manufacturing grid of the mask maker?
Oh, of the software. I mean, the value we specified in here is not equal to the actual value, the mask manufacturer's value.
Okay, the mask manufacturer. Okay, gotcha,
Yeah.
gotcha.
So, but if it's like bigger than that or smaller than, do they have the same?
Okay, so that's a great question, and that's a good way to think about it, right? So, typically, the way this sequence works is that, before the manufacturing grid is set in the PDK, the people who make the PDK talk to the mask makers, and they ask them, because, especially with the university designs, there's a variety of, mask makers out there. And, typically for, an integrated circuit, we're talking, those masks are done at, the fractions of, they're done at nanometers, right? So, there's typically not a problem, but there are some, especially if you're doing some sort of biology where, maybe your mask maker is at a 0.5 micron or a micron or something like that. So if you are designing finer than the manufacturing grid of your mask maker, then the numbers that you're putting in are just going to be truncated. So that's exactly what will happen, right? So if you're designing at a 0.5 micron, but your manufacturer only can do a micron, then any points that you put on a 0.5 micron are just going to be truncated to a micron. So typically what happens there, right? That typically things tend to work out okay, because you may have a your design will be truncated, but typically when the mask gets projected, it things smush out anyway. But it is important, right, to match the mask making grid with what you intend to do with the technology. So for example, here in our in the JFET PDK, the smallest line is 5 microns, so a manufacturing grid of a 0.5 micron is fine. But in an integrated circuit process, that would not be good, because in the integrated circuit processes, you're doing like tenths of nanometers, so the manufacturing grid's got to be way below that, right? So, and the resolution has to be below that, but they're all kind of related. The what can be done by the manufacturing house, the actual fab, and the mask maker go together, and that's why this conversation happens before before the software is set up. And so that's why, you know, if we look at, you know, if you, you know, and this is kind of an interesting thing to do, is if you pull up an integrated circuit example from ELEDIT, you'll see these numbers are very different than the numbers that are in the JFET process, that are even different than the MUPS process, right? So, you know, that's you know, that's how it works. The opposite being true is if your grid is bigger than the manufacturing grid, then you're fine. You know, you're just fine. You're just, you know, if you're designing, if your mask maker says they can print at 0.25 microns and all your numbers are on a micron grid, that's good. No problem. It's the other way, when you think you can resolve something that your mask maker cannot, that's when you have problems. And that's why we have a manufacturing grid here. And so what really happens with circles is they do get snapped to grid, and then they get printed, you know, in a way that may be different than you expected. And so that's why when you make a design, you should never depend on your coordinate being exact, right? When you're drawing curved structures. But when you're drawing things like, excuse me, like the transistors, the JFETs, you know, you've got to make them, you know, be exact, right? That the width, for example, of the gate of the JFET, you know, has to be bigger than a certain amount. And, you know, if it's bigger by 0.1 or 0.2, that's fine. It's but it can't be less than the design rule. Okay, so one of, you know, kind of the takeaway for this is that you as a designer should look at these numbers, make sure they make sense, and then understand where they came from. So in this case, when we look at the design kit tomorrow, the numbers came from the CMC, and they were chosen to match up with what the 3IT can do and the people who are making the masks at the 3IT. Okay, so does that kind of explain it?
Oh, yes, definitely. But like, I think maybe my last question is, will this manufacturing grade value affect the grid display values or override it?
Will it affect the what?
Will this like a manufacturing grade value override the grid display value?
The grid what? The grid, I couldn't hear you.
Grid display, the first section of this window. Of
Okay. So let me be clear about this. The grid display, these are just dots. The grid display are a bunch of dots that get printed on the screen, and so they have nothing to do with your actual drawing. So you could actually draw without a grid. Like, for example, this drives me crazy. SolidWorks has no grid. So, and I like having a grid because it helps me remember, you know, when I'm drawing, you know, exactly where my points are. But the grid display is independent of the manufacturing grid. The manufacturing grid is, you know, gets applied to the numbers. So like, for example, when you draw, you know, a wire or a box that is 5.1 microns long, and then we go to write out JDS2, that 5.1 will become either 5.5 or 5.0 most likely. And ELEDIT does, what it does is it snaps to the nearest grid point. So it takes the manufacturing grid and it takes all of the points on your polygon and it just snaps them to the nearest manufacturing grid. And that's independent of your grid display. So the grid display is not related to the manufacturing grid. It's just a picture. Does that help?
Oh, yeah, definitely. Thank you.
When we see the interface, I'll point that out for sure. And as I said, I know that for some of you who are used to ELEDIT, you understand this, but we're really going to take our time for the new folks. So please ask questions like this. This is a really good question. All right, so I'm going to keep going here unless there's more questions. So the other thing that we have in ELEDIT is the information toolbars. So these are really helpful because depending upon where you are on the screen, your mouse is going to do different things. So one of the things I do is just always check my mouse, because sometimes, I'm thinking that I'm editing an edge and the mouse thinks I'm editing the center. So check your mouse, and then it displays according to what the left mouse button, the middle mouse button, and the right mouse button is going to do. And most people, if you're like me, who just use a laptop and I don't even know where my mouse is, Alt plus left is the middle mouse button. Other people have, you know, a 3-button mouse. So if you do, then you actually do have a middle button. And so, for example, this information toolbar was set up. The person was over the layer setup, so they could hide or show their layers with the middle mouse button. And then the other thing that you want to look at is your status bar, which is at the bottom of the screen. Typically, if you're doing like a selection operation or some operation, then the status bar is going to show you information at the bottom. And one of the things that I do a lot is LEdit is very helpful. Like if you're drawing a box or a polygon, LEdit is going to give you the width, the height, the area, and the perimeter of that polygon. So it automatically calculates this information and shows it to you. So sometimes, you're drawing along, and you want to make a box that's, 36 microns, as you're drawing, LEdit will update that information for you so you can kind of see when you get there, or you can use your grid. So, glance down at the information status bar at the bottom, and you'll find a lot of useful information. Sometimes you have to draw things that exactly have a certain area. So LEdit is constantly calculating things like area for you and displaying it for you, so you don't have to do it yourself. Okay, so I've just added this slide as an information slide. And at the end of you guys have access to all these PDFs in the Dropbox. And so for each presentation that I'm giving, at the end, there is a bunch of information slides that are really too boring to present to you as a group. So I have added a bunch of, little information slides about things that you're going to find useful. But I wanted to put this one right in the main presentation because people always ask, what do the keys do in my setup. And LEdit allows you to customize, for example, if you would like a different key to represent, say, for example, panning and zooming, if you want to, instead of using the J and the K key, maybe you have used a different layout editor before and that tool used a different key. You can map the keys, and the one that gets used most often is cadence. So if you have a set of keys that you use in cadence, you can map them into LEdit. So LEdit will look like cadence for you. But typically these are the big ones. The mouse wheel will do vertical pan. You can zoom in and out using the plus and minus keys. And the most important key that I use a lot is the home key. And it's located somewhere different on everybody's laptop or computer, so you have to go find it. The home key is going to center the design in your window. And I find that very, very helpful. And the other thing that you can do is if you're designing very large and very small structures, you can toggle between a very fine view and a very large view of your design using the X key. So these are the keys that I find that I need to refer to a lot. And so when you're just getting used to LEdit, you can refer to this slide. And as I said, at the end of the presentation, you'll find a lot of other useful key mappings that I won't bore you by going through. Okay, so enough about grids and how to work with the information that LEdit gives you. So now let's talk about what we need to do to set up for drawing and how LEdit thinks about drawing. And understanding the way LEdit thinks about masks is really important for understanding the design kit and how the masks are defined by the manufacturer. Okay, so the masks in LEdit follow how they're actually used in the fab. So for example, at the top here, I've shown on the left, we have some silicon with some layers on top of it. And what happens in the fab is there's a mask that gets drawn. This orange thing gets printed into a physical mask. And then there may be some operation done in the fab where we're going to apply some sort of etchant, and the mask is used to block the etching of that material. So for example, then at the right-hand side, we end up with the material being only present where the mask was drawn. Now, there are different types of operations that get done in the fab, and there's different types of masks. And it can get very complicated because typically what's done in a real fab is you have a mask that masks off some photoresist, which then gets developed, and then the etchant is applied to the photoresist structure. So where the complication comes in is that you have the tone of the mask. Is it positive or negative? You have the tone of the photoresist. Is it a positive resist? Is it a negative resist? And there's a lot of different terms that get that get defined. And in fact, when we talk about the design kit, the CMC has discussed how the masks are made for the JFET process. But when you're a designer, you want to simplify things to a very easy way for your brain to think about it. So what's been done in the mask layout world is we have we think about what we draw. And so we call it a drawn mask. And so a drawn mask indicates, in this case, if we draw the polygon and we place that polygon in a particular area, if we have an inside or whole mask, material will be removed there. And if we have a drawn mask, which is an outside mask, it means that where we draw the mask, we're going to keep the material, and the material outside the mask is removed. So that's how LEdit and all mask makers, think about how you design and what you're actually creating in the layout editor. What happens behind the scenes is there may be photoresists that get developed, and then the mask itself may be printed in a positive way or a negative way. You might have heard of negative tone masks, positive tone masks, but all of that gets distilled down into two types of masks in LEdit. One for drawing where we want holes in our mask, and one for drawing where we want to keep our material. Okay, so we will discuss this more tomorrow when we talk about the JFET design kit. But I just want you to kind of keep in mind that we have these two types of masks, one where we draw the material that we want and one where we don't. And typically, although this is not always the case, in an IC process, we always draw things like metals or gates. We always draw them, using what's called an outside mask, or we always draw where we want the material to be. And we always draw vias or holes, contact, we call them contacts or vias or holes. We always draw in LEdit where we want the material to be removed, where we want the hole. So that's a convention that we have in the integrated circuit world. And that convention is not always followed in the MEMS world or the photonics world, but it will be followed in the in this JFET design kit. Is that correct, Priya?
Yes.
Okay, great. All right, because this is something that confuses MEMS people all the time. So hopefully for a JFET, it's all good. Okay. So now we have our masks, and what happens is that typically, when you send your data to be manufactured by your mask maker, you write it out in a format, as we talked about, called GVS2. And so each mask gets assigned a number. But for the purposes of drawing on the screen, we color our masks so that they can be, distinguished one from the other. But the color that you make your mask has no meaning whatsoever in the output of your GDS2 file. In fact, the color of your mask is not in your GDS2 file. And that's why we have the two different types of files. The TDB file knows what color your mask is. Your GDS file, or a DXF, well, DXF may know your color too, but the GDS file certainly does not. It does not know what color that is. So in LEdit, we have a display based on the color of the mask, not based on the GDS number, because you would go crazy if everything was the same color and then we just had little numbers that told you which GDS number it was. So instead we color the masks and we put them in a table and we give them names, even though when they get written out by computer in GDS, it's all the same color, the names don't matter, it's all about the number. So here is the palette, the way that you select your masks based on color is how they're represented. So the compact layer palette will show you different layer names, and then the color, when you can either select a layer by its layer name or by its color when you're going to go draw. And then, as I told you, the mouse can operate on this little, mask palette. And so if you click with your left, you're going to select a layer. If you hit the middle mouse button, you'll hide or show that layer. And then on the right, you can also lock or unlock that layer too. Locking a layer means that you cannot draw anything on it while it's locked. Okay, and then the other thing that you can do is you can filter your layers. And we will talk about that a little bit when we discuss the design kits, because you are going to draw on layers that we care about for the JFET. Like you'll be drawing the gate, you'll be drawing some metal that connects the gate, but there's also other types of layers that LEdit uses. So you can filter them so that they're shown, you only show the layers that you want. So that's what the little thing at the top does. It displays all of the layers, or just the ones that you're drawing with, or just the ones that you're using, and things like that. And so one thing that's really, really helpful that we're going to do quite a bit is we're going to turn on or off layers so that we can just look at some of them, because sometimes it's hard to see if we have multiple layers on top of each other. So for example, in the JFET design kit, we have the diffusion region and then we have a gate. So sometimes it's good to see maybe just all the gate regions. So we can turn off all the other ones and just view the layer that we care about, or combinations of layers. And so this is really, really helpful to be able to turn them on or off. So you can right click in the layer palette, and that shows or hides the layer. It's like a toggle. Okay, so if it's, we can do this in the design that you have. So I'll go ahead and switch to LEdit and show you that live. So you can, if you want to select the layer palette, you click on the colored square that you want to see or not, and then you can operate on that layer. So let's go do that in our design. I don't know what this wants. Okay, my computer just does things every once in a while. Okay, so we have our design here, and you can see I've got a lot of layers and stuff. So I can go over to the right-hand side, and here's poly 0, which is the zero layer, the first layer of polysilicon polymumps, and I can turn it off so that I can see all the other layers present. And for example, I may have a stack of layers here, especially in the pads, where I might want to turn off the metal layer, so I can see the poly 1 and the poly 2 that is underneath it. So turning off layers is really helpful, and I can turn off I can hide all of them if I want to, so I can just see the metal layer. So for the JFET, it's a pretty simple process, so you may not have to do this, but it's good to know for other projects that you might be on. Okay, so let's go back. There is also a layer palette. Is there more questions? I don't know, in the chat, Priya, you're watching the chat, right?
Yes, just Rana says he can't see the grid layer. If you could show that.
Oh, okay, great. All right. You want to see the grid on the, okay, yeah, we might as well address that right now. Okay. Why can't I see my grid layer? Because I'm zoomed out really far. So if I will show you how to zoom later, but I'm going to go ahead and do it. Now I'm zoomed in. So now I can see my grid, and I will show you how to zoom later when we talk about viewing. But the reason why the grid was not shown was when we're zoomed out like this, your screen would be full of dots. And so what ELEDIT does is when you are very far zoomed out, it's going to suppress the grid. And that's why you can't see it. So we'll get to that maybe in half an hour or so. We'll talk about how to view, but yeah, go ahead and stop me at any time if something seems weird or whatever. I can talk about it then, and then we'll discuss how to deal with it later. But what I was doing with my screen here is I'm actually, you could probably even use the plus and minus keys. And now you can see there's a slightly darker spot where that's the major grid. And then you have the little small dots, which are the minor grid. So the major grid in polymumps is every 10 microns, and the minor grid is every 1 micron, as we saw. So for example, these bars here, for this comb drive are 4 microns. So they take up 4 grid points. Does that answer your question?
I meant the toolbar on the left side, but I found it finally, so thank you.
Okay.
Yeah.
Okay. Okay. All right. Super. Yeah, just stop me, Priya, if someone, I can't read the chat because I got to focus on the switching back and forth. So.
No problem.
Okay, great. Yeah, or just somebody, if you don't want to chat, just, I mean, if it's easier for you, just, unmute yourself and go for it. Okay, so the other thing that we have is a bigger palette. And remember I told you we had those docking views. So if you go into view docking views, there's another layer palette there. And so it has more information. I tend to not use it because it just takes up too much room on my screen. But you can use this palette if you like. And it has more, it can do more things for you. So for example, here it shows you it has a filter just like the other one. It also shows you whether the layer is hidden. It shows you the GDS number, which is helpful sometimes if you have a lot of GDS layers in your design. So it's a lot bigger palette and takes up more room, but you can use it if you like. It's the same as the smaller one that you can select and hide and do things like that. It has the same color icons. And the thing that is also true is you can have multiple layer palettes. So for example, suppose you have, a design where you're designing, some structures and you want to have some layers for doing one part of it and a different set of layers for doing a different part of it. You can actually even set up multiple layer palettes. But I think if you're a beginner in ELEDIT, you're better off, excuse me, just using the simple palette and going from there. Okay, so now let's talk about this is also for your information. This is all the things you can do with this layer palette. So I'm just leaving this in here for you to be able to refer to it if you want to use this particular layer palette. So what happens if we hide and show layers? So here, for example, I did a little demo. I've hidden all but the blue layer there. Now we can see the details of this routing in this magnetic actuator. Was there a question? There's more stuff in the chat. I wasn't sure.
No, nothing at the moment.
Okay, great. Okay, so those are the layer palettes and what we can do to hide and show layers. So now let's talk about how to draw stuff. Okay, and so now we're going to use the drawing toolbar. And one of the things that's really important about L-Edit, which is different than AutoCAD and other layout editors, is that if you are drawing things like boxes, you will keep drawing them. In other tools, you have to select what you want to draw, you draw it, and then it stops and waits for you to select it again, what you want to draw. But in L-Edit, for example, if I'm drawing a box, it will draw a box, and then I point again, it will draw another box, and a third box, and a fourth box. So people using L-Edit often get a little annoyed at the beginning because, you just want to draw one box and be done. But it will just keep drawing whatever you had before, whatever you have selected. So then you have to go to the selection tool when you're done drawing and you want to do something else. So that's something that, you have to get used to when you're drawing with L-Edit. I, often have this problem myself. so it's just something we have to be aware of, and you'll get used to it. So I will remind you, and in the exercises that we do, we always remind you to go back and use the pointing tool when you want to select something. And so this drawing toolbar, excuse me, we are not going to talk about everything on this toolbar, at once, and maybe not everything, today. But I will point out all the things on the toolbar, and then we'll discuss the ones that we're going to, start with. So is on the left-hand side, we have this little pointing tool that's how you select things. So if you're not in selection mode, then you're drawing, and you can limit yourself to drawing boxes or polygons. And you can see there's different types of polygons. You can have 90 degree, 45, or all angle polygons. Later in the day, we're going to talk about wires. If you want to do some routing, wires are easier and quicker to draw. They have a different representation than how we draw polygons. We also have our circular objects that are shown here. And then we have these objects called ports, which we're not going to talk about in this class because we don't have time. But we can use them for connection layers if we're going to do some things where we, for example, see what's connected to what. We may, if we have time, talk about text labeling, but I'm not sure if we'll get that far. The other thing we will talk about is there's various types of rulers in L-Edit. And then the last two items I'll talk about a bit later. And those have to do with how we're going to compose, a set of objects into groups. So we'll talk about that at the end of this section, actually. But I want to get you drawing and able to start working with the tool because I've talked for a long time and we haven't drawn anything yet. So let's get to drawing. So in L-Edit, you'll see we can have multiple windows open at the same time. So one of the things you have to do is make sure that you activate the window that you want to draw in. And we'll talk more about windows later, but the when you have a window and it's highlighted or it's active, the color here at the top of it will change a little bit. And we'll see that later. It'll be a little bit brighter. So that's how you can be sure you're in the right window. And then you select the layer that you want to draw on by clicking on its icon in the palette. And then you select the shape that you want to draw. Maybe you want to draw a circle, maybe you want to draw a square, and then you click and drag. And in these slides here, I've shown like when you're going to review later, I've shown the mouse position of how you do it. So you click and drag with your left, and if you're drawing a box, then it's it's just the 2 clicks that are needed. And also in L-Edit, which is different than AutoCAD, all polygons are closed. So every box, for example, is represented by a start corner coordinate and an end corner coordinate. So all polygons are closed. There are no open regions like there are in AutoCAD. Okay, so if we want to draw a polygon, we select one of the 3 modes: orthogonal, 45, or all angle. And in all 3 modes, we start by drawing using the left mouse button. Then we create as many vertices as you want with your left mouse button. And then to end, you use the right mouse button. So in the picture I've drawn here, we have 1, 2, 3, and then we ended the polygon with the right mouse button. And so polygons are defined by the number of vertices and their respective coordinates. And we'll see that when we start to edit them. Okay, so now let's talk about curve shapes. As we discussed earlier, we know how to turn on our curves. 3 curves are available. We can draw circles. And one of the things that's important about L-Edit that makes L-Edit very efficient is that in some layout editors, if you draw a circle, it's really a polygon and you have to edit it as a polygon. But in L-Edit, we have actual circles that are represented by the center and the radius, so that when we edit them, they're a center and a radius. Now, I've heard that Cadence has now added this capability, but you'll see later that we have even more curves available in L-Edit. So we can also draw a pi wedge, and we can draw a torus. And so I've shown you the sequence of mouse clicks if you want to draw any of these objects. Okay, so any questions about that? I'll go ahead and draw some stuff for you before I move on and talk about some of the other aspects of the tool. So basically, I'm just going to go ahead and mess up my resonator here by drawing some stuff. So as I mentioned, since we only have 1 window, if you're not sure if it's selected, you can kind of move it around. And when we talk about multiple windows, you'll see the difference between, when a window is activated and when it's not. But you just want to make sure that you're in the right window. Then you choose, for example, that you want to draw. I'm going to draw on poly 1, and I'm going to draw a square. So I just click and drag. Now notice, if I just do this again, I'm going to keep drawing squares. So if I want to stop, I got to go over here and hit the selection tool. So now I'll go over and I will draw a circle by setting the center and the radius. And if you notice, if I just click again, I'm going to get another circle. So I got to go over and, I got to go and, sorry, my mouse is not tracking. I have to go over and go to the pointing tool. So that's how you start to draw objects. Now, let's go back to the slides. We also have some advanced objects that are present on what's called the MEMS Pro toolbar. And this toolbar is going to allow you to do some, advanced type of drawing functions. And we won't go over everything today because it's got a lot to it. We hit most of this in the advanced class, but I do want to draw your attention to the special curves that are present on the MEMS Pro toolbar. We can draw things like splines, ellipses, spirals, and other types of curves that are not available in Edit. So if you need to do that for some of your routing, we also have some things in our library that are helpful for biologists. So if you want to learn about that, you can take the advanced class, but we're going to just focus on a few simple things in this simple class. And normally the toolbar looks like this. If it's not present or for some reason you can't find it on your interface, you can go into the tools menu under macro and click on load. And I'll be demonstrating this in a second. And then you can browse to the location of the toolbar and hit open. And that will bring the toolbar back so that you can, make sure that it's there for you. And then in this little macro menu, you can hit run. And I'm going to demonstrate this so that you can see it. So let me go do that now. I'll show you the toolbar and then how to get it back. So mine is being blocked a little bit by this window. So hopefully you can see it. Can you guys see my MEMS Pro toolbar?
Yes.
Okay, great. So here are the curves, these splines and parabolas, and these are all available in polar coordinates. So what happens is if somehow you lose your toolbar, you can't find it, those slides show you how to get it back. You go to the tools menu, then you go down to the macro section, and you will go to macro. And if you can't find it, you'll just go ahead and click on run, and that will bring it back to you. Okay, so if you can't find that toolbar, those slides will help you get it back. Okay, so hopefully all of you have this menu available to you, and if you need help accessing it, then we can show you at the break. And what that toolbar does for you is it allows you access to these special curves, and they then allow you to extend the what you can draw in Edit using polar coordinates. And so you can get some pretty pretty complicated shapes. For example, using these curves, you can get things like these tapered, you can do elbow bends, you can do tapered structures, you can do microfluidic wells and mixers, a lot of things that are important for biology. So these are all the things that you'll be able to draw with Edit, just to remind you. Was there a question? No?
So where do the macro files get saved?
Where do the macro files get saved? Okay. These macros that, there are macros that are written already in the tool. So for example, the MEMS Pro toolbar is already a macro that ships with the tool. And so you're able to load them directly. In fact, macros can be set up so that when you pull up the tool, the macros are available to you right there in Edit, and you don't have to know you don't have to think about their location. Other macros, if by mistake you close them or something like that, then they are in the shipping directory with the tool. And as Priya showed you, as Priya will show you in the design kit, you can write your own macros and you can put them in places that will be automatically loaded with the tool, or you can put them in your own directories and then just launch them or browse to them. So ELEDIT is very flexible, so it allows you to add things to the tool if you put it in a special place, or you can put your macros anywhere you want and then just refer to them. Does that answer the question?
But when I open the macro and I try to load it and it's empty, so I just need to know the directory.
What do you mean empty?
Well, if you go to setup and the macro, and on my screen, I don't have default files. And if I click load, where can I go?
Okay. I understand. Okay. All right.
Yeah.
Let me do that. Let me show you that. Okay, here you go. I think I understand your question now. Let's go there. Okay, so if you, for example, let's close our MEMS Pro toolbar and let's go and, okay, I'm going to unload the macro. So this is what you saw, right? Okay, so now, and we can go to load. And where the macros are normally stored, and I've put this in the notes for you, is that the soft MEMS macro is located here. It's called memsphysical.dll. So you click on it and then you click and hit run. And that's what the notes say. Let's go back and look at the notes. You go to click on load. So we had a blank screen and we hit load. And then here's the location. See program files. This is where all your soft MEMS information is located under MEMS Pro V11. And so you just highlight that DLL and click open. Okay. Does that answer your question?
Yes, thank you.
Okay. Sure, no problem. Anyway, if anyone else has the same question, just stop me anytime.
Miriam, there's one more question from Nang. So is this curved polygon only available with MEMS ELEDIT?
Yes. No, there's two types of curved polygons. Let me be clear. Let's go back to the ELEDIT screen. There are the polygon, oops, oh, I can move that around, good. There are, oops, I'm gonna get out of this. Oh no, I really, okay, hold on. I'll have to hit something. So if I look at the screen here, you'll see there's a three types of structures: the circle, the pi wedge, and the torus. Those are in regular ELEDIT. Okay.
I cannot find these three in my toolbar. So have you said?
Okay, we talked about that a little earlier. If you right click here and go down to all angle and curves.
Oh, okay. Thank you.
Yeah, they will appear then. Okay.
Oh,
Were you able to get it?
Yeah. Oh, so, yeah. Thank you.
And that's in the notes. So if you forget, it's in the very beginning here. Let me find it for you. On this slide here, slide 11, it says go down to all angle and curves. Okay.
Oh, okay.
So if you don't see them, you get this. And if you go and you right click, you get all angle and curves and they appear here. Or you can go to setup application, which we'll talk about later. You can also get your all angle and curves there. Okay.
Okay.
Any other questions?
No.
Yeah. Okay, sure. Anything else, Priya? I'm sorry?
No.
Okay, so now we can draw stuff. And so the question was, you know, these curves here, I think there's a different question. These curves here, which are the special curves, are available in MEMS Pro. So the CMC has a bunch of licenses of MEMS Pro. So Priya, maybe we should talk about that later, is how to make sure you have MEMS Pro. I don't know how to do that at CMC, but how do they make sure that they're running MEMS LEDit and MEMS Pro so they can get the curves?
So usually when they load for mentor, it automatically they have selected both.
I couldn't hear you. You were cut out. It automatically loads what?
They automatically have access to both once they load. Yeah.
Okay, so they just have to make sure they're running MEMS LEDit, correct?
Yes.
Perfect. Okay, that's your answer. That if you run MEMS LEDit, you will get this toolbar, and I showed you how to get it back, and you'll have access to these curves and all these other features. Was there more questions that came up?
No.
Okay, great. All right. So the other thing that you have access to that I'll point out, we talked about these curves. You also have access to things like some service functions, like for example, to draw a regular polygon. So if you want to draw, you know, in LEDit, you can draw polygons by clicking, but if you want to be sure that you have a hexagon or a pentagon, MEMS Pro allows you to draw these polygons, you know, and specify the number of edges, the radius, the rotation, things like that. Because sometimes drawing a perfect pentagon in LEDit by just clicking is a little difficult because you have to calculate, you know, exactly where you want to be. But in MEMS Pro, we have a regular polygon feature. And then we also have the capability of bringing in polygon points from a external text file. So if you have a text file, maybe you calculated it with you know, with MATLAB, you can read in a file of points with MEMS Pro and be able to display them. Okay. So was there another question?
No.
Okay. All right. So now let's go on to editing and selecting. I think we have about 8 minutes, but we'll see how far we get. This is the first section that's pretty long. Okay, so now to select objects, make sure you're using the pointing tool, as I told you, because you think you drew all your polygons and now you want to point at something and oh, you forgot that you're still in polygon drawing mode. So instead of selecting it, you draw another polygon. So make sure you're selecting using the pointing tool. You point at the object you want to select, and then one of the things that, depending upon how the design kit is set up, and Priya, we should check this, is the object may change its border color depending upon how you know, how the rendering was set up in the layer palette. So for example, I could have my object color be blue, but when it's selected, I could put like a red border around it, and most of the times design kits are set up so that either the edges become enhanced in some way, the object color changes, or there's a different color border. So that's something that you can change, because sometimes, you know, if you've got a lot of polygons on a screen and you try to select something, you're not sure if that object is selected, especially if there's a stack of objects. So changing the appearance when it's selected is often a good thing to do. If you have layers that are hidden, they're not selected, and that's very helpful. So for example, you know, if I want to only select, you know, my metal objects, metal pads or something like that, I can hide all the other layers so that I don't accidentally select one of them. And the selection is indicated in the message bar at the screen bottom. And if multiple objects are on top of each other, keep clicking and the selection will cycle through the objects. So let me demonstrate this because it's kind of important. Unfortunately, you can't see where I'm clicking, but we'll do our best. Okay, so on this pad here, I have a bunch of layers stacked on top of each other. I've got metal, I've got poly, I've got poly 2. So you can see here, I am now you know, I'm selected, say like if I'm here, I'm selected a box on poly 0. It shows me what is selected. If I go over here and I click on this circle, it says that I have selected the circle on poly 1, and it has this radius, blah, blah, blah. So you want to make sure you're in the pointing tool, and then you have the appropriate layers turned on that you want to see, and then you'll be able to select them more easily. Okay, so let's go back. Okay, so I'm going to close the preview of tomorrow and get back to where we were, and we'll get on to cells like I promised after we talk about editing. Okay, so we talked about the fact that we can edit a single object. So to select multiple objects, we can click and drag a box to select multiple objects. So for example, here we have this person drew a box and they selected 22 boxes. So at any time, if you're in pointing mode, you can just click and drag, and that will select multiple things. And you can also select an object and then hold down the shift key, and you'll keep adding to the selection. And then the other thing you can do in the view menu, there's a select all. And so if you wanted to select all the objects on a given layer, for example, you can hide all the other objects and then hit select all, and then you'll get all the objects on a given layer. Okay, so that's selecting multiple objects. So now I'm giving you a little reference slide. So about object selection, just for your reference. So if you hit escape when you're doing a drawing or editing operation, that will cancel it. If you hit escape again, you can switch to the selection tool. Control A selects everything, Alt A deselects everything. And then what happens is sometimes you have things on top of each other. So if you have like, a pad cell, you can have layers that are just on top of each other. So you can just keep clicking, and Edit will cycle through all the layers. So if you have a stack of 5 layers, 5 objects on top of each other, just keep clicking, and Edit will cycle through object 1, object 2, object 3, object 4, and it'll show you in the in the selection, it'll show you, like, for example, I selected a box on copper, and if I click again, I might get the box on poly. So if you can't, you don't have to move things out of the way to select them if they're on top of each other. And if you want to add to the selection, you can do shift. You can remove from the selection. And if you want to select an edge of an object versus the center of the object, you hit control, and that will select the edge of the object, and then you can add or remove an edge. So this is kind of a reference slide for you until you get used to Edit, and then after a while you won't have to refer to this. So that's drawing and selecting. So now let's talk about editing. And so now we're going to look at the editing toolbar. Just a second, get some water here. This toolbar gives you access to these features. You can duplicate, you can rotate, you can flip. You can also slice a polygon, which is often very helpful. And then the thing that we're going to talk about next is that we can merge and group objects into hierarchy, which kind of gets into what we were talking about earlier with the other gentleman. So we'll talk about that a bit later. And you can also edit an object graphically, or you can edit it textually, and we'll see how we do that. And then we can also move objects by their coordinates if we want to be very precise about, making objects move in a very precise way. So to edit an object, we select that object using the pointing tool, and then we click on the edge and use the middle mouse button to change the edge position. So you can see here that if I click in the center of an object, my middle mouse button will say move, and it will move that object. If I want to stretch the object, I click on the edge of it, and my mouse will indicate that I'm editing that. And so that's a bit annoying with Edit. So you have to make sure that you look at your mouse. Am I moving my object? Am I editing my object? And so you'll get used to that. So the mouse toolbar will help you. So in this case, the left and the right are the selecting, and the middle mouse button is how you move. And as I said, if you don't have a 2-button mouse like me, a 3-button mouse like me, I do Alt and left, and that replaces the middle mouse button. Okay. We also have the capability of textually editing. So we select the object, and then we use Edit Object or Control E. And in the Edit Object dialog, you'll be able to modify the parameters and things like their coordinates. And this gets at that question: is a circle really a circle? The dialog is customized by the type of object. So, for example, when we're editing a torus, we are going to edit it by the center and the 2 sweep angles, because a torus is represented by those parameters because it's stored as an actual torus instead of a polygon. Okay, so if I have a polygon, I'll have a list of points. And so that's why a circle really is a circle in Edit, because it doesn't store it by its polygon points, it stores it by its radius. And then the other thing you can do is you can also change the layer on which an object is drawn. So for example, suppose you screwed up and you made a bunch of metal wires, and oh, you meant really for them to be on metal too. You can select them and change their layer at any given time. And then the other thing that Edit does that's really great is that you can grab a bunch of objects and edit them all at the same time. So what Edit does then, as we told you, there are different editing paradigms based on the object type. So if I'm editing a box, I want to set say the lower left and upper right coordinates, or the center and the width and height. But if I'm editing a circle, it groups all the circles together, so I can edit them by their radius and center. So I can edit my objects based on object type. So I can select a bunch of objects, and then Edit will say, okay, let's edit all the boxes. And then you can go to the circles tab. Okay, let's edit all the circles, blah, 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 blah. And so what you do is you choose the tab that you want. Like suppose you selected 12 objects and you had 3 boxes, and then Edit will edit them one by one. And the way it does that is it will actually move the focus of the center pointer to the object that it's going to edit, and so you can see it, and then you can change the coordinates of that particular object. So let's take a look. So here, for example, if I'm editing my torus, it will go find the torus, and it will then offer for you to change the torus parameters. And you can then go from one object to the next with these little, with the little next and back keys. So that's how we would highlight through the objects. Okay, so in Edit, when you're just beginning, you probably just are going to edit each object by itself. So, but when you get more advanced, you may choose to do some all object editing by doing a selection. Because, for example, suppose you screwed up and you made a bunch of circles, all of radius 5, and you have 50 circles. That would be a pain to go through and click each one. So Edit will then offer for you to just change them, and you'll be able to quickly modify a parameter that you set by mistake. And so with the editing features, we'll be able to create a lot of very interesting shapes based on the objects that we drew, and it will be editing allows us to correct to correct our mistakes. And a little bit later, we're going to learn about Boolean operations. So I showed you the rotate, the flip buttons, things like that. But we'll talk about Boolean operations where we can and or objects. And we can also do things like merge them. But we'll be discussing that later in the afternoon. And we'll show you how to make arrays of objects. We'll actually do that this morning. Or sorry, I'm referencing to West Coast. Sorry, afternoon West Coast time. Okay, so those are the editing features. I am going to give you your 5-minute break, and then I'll do a little demo of editing, and then we're going to move on to the onto hierarchy and cells. Okay. So now I'm going to talk about viewing right before we start the cells. And we talked about the docking views just briefly. Let me see, I am screen sharing. Okay, good. So we will be using these views later, actually fairly soon. The first view is a library and cell list. And in the PDK that we have for the JFET, there's a bunch of predefined layout that you will be able to pull into your designs, and you'll be using the library navigator to do that. The layer palette that we talked about is also a docking view. We talked about that there's a command line window, and then when we do the DRC, there's also the verification navigator. For circuit people, there's a schematic driven layout navigator. And then we can also look at our layout in various ways with the aerial view navigator. And then we're going to talk about finding objects in a hierarchy. So there's also a navigator for that. And so the different navigators can be put in little tabs, or you can, as you saw before in the beginning, we can have them all as separate windows in the interface. We also have the normal viewing transformations that we have the keyboard shortcut, zoom in, zoom out, panning, redrawing, and we can also zoom. The W key is kind of a neat one. It zooms to the selected object and puts that in the screen. So now we can draw things, we can edit them, we can view them, and now we're going to learn how to group them. But the last viewing feature that I actually used earlier when someone asked about the grid was the box zoom. So if you hit the Z key and draw a box around the corner of your layout, you will zoom in, and you won't be able to see me see what keys I'm hitting, but I will try to demonstrate this. So I'm hitting the Z key now, and you see that it allows me to draw a box, and then goes ahead and centers that what I drew the box around in the screen. So now I'm just using the minus key. I'll use my Z key again. I drag a little box, and now that is in the center of the screen. So that's really helpful. As I said, you can use the home key also to home the view, and you'll be able to now properly access different parts of your layout for editing. So now we're going to talk about cells and so that's what we were waiting for. Oh, did I answer the question about the editing of circles? There's a person that had a question about editing circles and the representation.
No, I think you missed it.
Okay, so let me go do that because that clicked into my mind. Okay, so let me zoom in on my circles here. Okay, so if I have my circle here, and if you see, it says it's a circle on poly 1 layer. If I do edit object, you'll see that it's offering to give me the center and the radius of that circle, okay? So it's really representing that thing with its center and its radius, okay? Does that help?
Yeah, that's my question, I think.
I'm sorry, say again?
That was my question.
Perfect. Okay, great. All right, so now we'll move on to cells. I remembered there was some question that I hadn't answered. Okay, so let me find my PowerPoint. Okay, so now let's talk about cells. Okay, so L-edit is hierarchical. Yeah, sorry. Was there a question? No? Okay. So L-edit is hierarchical. And so your design contains, as we saw, your design contains sub-design called cells. So we can design like an object, like an ellipse or a circle, an individual object that's just a circle by itself, or we can group objects together. Like here, we've grouped this circle and the square. And we can also group an individual object, and we'll see why we would want to do that in a minute. And then we can create a design where we take these objects and we just, they're not actually copies, they're copies of the base object. So here I've put my two objects, this blue, they're called cells. I put the blue cell in twice into my big design. And now I have this other one and I've put those two together, and I can even overlap them. They don't have to be separated by white space. I can even overlap my cells. Okay, so in L-edit, we have what's called a design hierarchy. So the cell is the most basic building block of a design. And the idea of a cell is actually common to a lot of layout editors. Cadence also calls them cells. I don't know what they're called in AutoCAD. I don't know if there's any AutoCAD users here, but they are often called cells in the integrated circuit world. So I may have a bunch of cells that I drew. These are my designs, but I could also have a bunch of libraries that come from, for example, Priya has created a bunch of cells that you can use, and she put them in the design kit. So we're going to actually, in the next section, we're going to learn how to pull cells from external libraries. So you're going to have a file that has your design, and you're going to be able to pull in a library of cells from the design kit. Okay, so your design, which is this red thing, will have your cells that you made by yourself that you drew, and then we'll also have cells in it that came from an external library. And you can have more than one. You can have library A, library B, library C. For the JFET, for the JFET designs, you will most likely just have a library that you got from the design kit. But maybe if you're working in a team, somebody from the team may develop a library of cells, and then you can use them in your design. So you might have the PDK library, you might have a library from your neighbor, and then you have yourself. So, these files, the L-edit design database or the TDB file, will contain all of the cells that you drew. And then you can, the library cells are pulled in by what's called a reference. That means that they're not actually stored in your TDB file, but rather a link is made to the library file. So when you load your design, you have to make sure that that link is present so that you can pull in the library cells. Now, you could make a copy of the library cell and rename it and break that link so it's now your cell. Or you can keep the link and then say, for example, if Priya, who's in charge of the library, changes something in the library cell, you'll see that change. So there's these things called internal cells that you are drawing and you are creating, and then these reference cells that come from the library that are controlled by somebody else. And so when you use a library in L-edit, you cannot change the layout in that library. So if you want to change a library cell, you should copy it and make your own private copy. Okay, so this is how the hierarchy in ELEDIT gets created. And so, as I said, you can borrow cells from libraries, just like you borrow books. And then a cell in ELEDIT can contain 3 types of components. So they're primitives, or the little objects that we drew directly. They can contain parameterized code, which is what we're going to get from our design kit. Priya wrote some parameterized cells that you'll get to use for designing your JFETs, and also references to other cells. So the library, it could be a reference to the library. It could be a reference to a cell that you've made yourself, or it could be an individual object or a parameterized cell. So that is all the different things that you can put in your design. And we'll take a look at this in a minute, an example. The design navigator shows all the cells and the libraries in your design. And that is one of the windows that we talked about. The docking views is the design navigator. So what I've shown on the screen now is a picture of a design navigator view of a design that someone did for MEMS, which was a magnetic actuator. And you can see it has these little pluses and minuses, because you can see, if you see here, you can expand, because cells can have cells inside them. And so you can, show what is inside of what using the little pluses and minuses. And you can arrange your cell list in many different ways. And as we talked about, we can have a parameterized cell, and that looks like this. We'll learn about parameterized cells in a few minutes. And then we also have cells that are locked. So that's a part of a design that someone else did, or maybe you did yourself, that you want to make sure no one can change it. Okay. So here, this is a library cell. This little bottom copper wire is from a library. And so that cell is used in 2 different parts of this design. And typically the library cells are colored blue. So if you see a blue blue cell listed in the design navigator, that means it came from a library, and you won't be able to change it because it was designed by somebody else. So we talked about the design navigator, and that shows us the hierarchy. We talked about the little special symbol. That means that this is a programmable cell. So now, how do I create a cell? Because up until now, I've shown you how to draw individual geometry, like a polygon or circle, what have you. But how do I make a cell? So then once you've started a design, you can create cells. So either you can open an existing design, or creating a new design, you can create a cell. So there's a whole menu called the cell menu that gives us operations about cells. And it's in between the view and the setup. And it's called the cell menu. And so new cells, if I want to start out a new cell, I press the N key. And we're going to be doing a lot of this. So you can either press the N key or go to Cell New under the Cell menu. And when you do, you will bring up the Create New Cell dialog. And today we're just going to, well, for this short section, we're going to talk about the first tab, which is the General tab. So cells have names, and then you can put information about the cell if you want. And then you can also open it in a new window. So, and as I said, you can also have, you can create cells in multiple designs or libraries. So you have to typically indicate the name of the cell. And in ELEDIT, and other programs, you can have different views of the cell. So we're going to just, in this very simple class, we're going to talk about layout cells. And that's that means that our cells are going to have layout in them. There's other types of cells that can have other things in them, but we're not going to address those in this simple class. And then the library typically is everything in LEdit is a library. Even your design is your own library. So they call it the library that the cell is in. So then you can set the things like that. So cell names cannot contain spaces, colons, or asterisks. And the reason why that is the case is that GDS2, which is when we write out all of our design data, GDS2 is hierarchical. So that when you write out your file in GDS2, you are actually writing out the cell hierarchy. And inside the cell hierarchy, you're describing all the polygons in each cell. And GDS is a hierarchical file format that contains all of these cells. And it's a very old format. So back in those days, they couldn't handle spaces, colons, or asterisks. Remember back in the old days when parsers were really dumb. So it's not a restriction in LEdit, it's a restriction in the file format that is most often written by LEdit, which is GDS2. Because you don't want to design, something that has 1,000 cells, and then you go to GDS out and you go, oh my gosh, I have to change all those file names. So LEdit prevents you from what it knows you want to do, which is to write GDS, okay? Then you can set the description and information about that particular cell. And most people just leave this blank, but people are very serious, like often PDK designers, you want to know who created that cell and what version of the cell it is and stuff like that. And then also, if you make a cell, do you want to open it in a new window when you create it, or do you just want to replace the view that's there? Okay, so that's one way of creating a cell. And that was the old way in the beginning of LEdit. LEdit's 25 years old. But now, like for example, in PowerPoint and other modern drawing programs, you have the grouping commands, right? So you can group a bunch of objects together and say, hey, I would like to create a cell from this group of objects. So there's two ways to do things in LEdit. One is to make a blank cell with nothing in it and then draw stuff inside. Or you have a bunch of stuff and you decide, okay, I would like to make a cell now because I might find this useful to be able to make copies of the cell and things like that. So if you have a bunch of LEdit objects, you can just do a grouping of them and say, I would like to make a cell. And you can also ungroup. So this grouping command is very similar to what one would do in PowerPoint, for example. Okay. So then I'm going to do a demo of this. So if you want to follow along with me, you're welcome to do so. And so I'm going to use the grouping method to create a cell. And we are going to do the other method many times in other parts of this class. So I'm going to go ahead and use the grouping method, and let's go ahead and do that. So if I have LEdit over here, and I am going to just cruise over here, I'm going to select some objects, and I can just do that by drawing a box around them. And if you see, I have two boxes and a circle selected. So I can go under the draw menu and I can use group, or I can just hit Control G. But since you can't see me do that, I'm just going to hit group. And it's going to bring up the dialog that says, okay, what's the name of this cell that I'm creating? And I'll call it, something boring, my box circles. And then you can also set the origin of the cell because, you need to know how these objects are now referenced to an origin point. So now when I click OK, you can see now there's a little box that's been drawn around it. And you can see it's been given a name, My Box Circles, and you can see my design navigator has changed. So now I have a cell called My Box Circles. I guess I should have called it My Circle Boxes, but in any cases, now I have a grouping that I can move around. And because now I have an object that's a cell that I can move around instead of selecting the individual circle boxes, whatnot. I can just move that around, and it's a cell. Okay. So now this is a way that I can group. All right. I can also, use the other method, which is cell new, and same very similar dialogue comes up, and it wants to know a cell name and whatnot. So we'll do that in a minute, that method in a minute, but I just wanted to show you the grouping method for creating cells. Okay. And now I'll show you something, the next thing, and that was the instance command. Now we can edit that instance in various ways. So I am going to show you how to edit the instances to make an array. So when I have an instance, which is a link to a cell, I can now modify how that instance is described in the cell context. So let's take a look at that. All right, so I have this particular instance, and if you notice, I have 3 of them, right? This one is over here, this one is facing this way, and this one is sitting here. So they're all links to a base cell, but I can edit the way this particular one is displayed, and I do that by editing the object. Remember, we edited object, we edited a circle, we edited a square. Now we can edit that particular linked reference. So I can rotate it. I could, set its rotation to be 45 degrees if I wanted. So now I have rotated that particular instance. I can go back, edit object. I'll change that back to 0. I can automatically make an array if I want. I can make an array of 10 by 10 of these little comb drives if I want. I can do that, and these are 10 by 10 identical copies of the comb drive. Okay, so now to show you that these are by reference, let's go and modify the cell. Okay, so now we have the My Resonator cell, right? So now let's do cell open, and let's open the comb, right? So now if we go in, we can actually modify and add, we can add a little piece to our cell here. And then so now we're editing the comb right cell. We did cell open. Now, if you look at all of the little, if you look at all of the copies, they all have been changed, including this one, right? And so they all get modified by the change that you made to their base cell. So that's the idea of how hierarchy works, is that you create a base cell that you draw, and then you use that in the hierarchy, and they're just references, or I don't want to use the word copy, but they're references to the original. And if you change the original, all of the copies change. Does that make sense? Yeah. Because this is the key. This is the key to understanding the hierarchy, right? Okay, so we talked about editing instances. and we can make arrays now. And we also talked about how when you change a cell, it changes all the instances of that cell. So now you've got the basic for drawn cells. So now I'm going to answer the question that the other person had, which is about how to use programmable cells. And I'm going to take away your 5-minute break. So hopefully that's okay, because we got lots to do. So now we're going to talk about programmable cells. So, and we're going to start a new cell, because remember I told you you could group things together to make a new cell, but now we're going to make a new cell using the other method. And we are going to instance a programmable cell. So I'm going to clean up my mess here by doing cell new, and I'm going to call this my prog. So I'm pretty, and I'm going to open it in a new window. Okay. So now I have a new cell. And if you notice, when I start a new cell, it gives me an origin, a little cross, and nothing else is in there. So now what I'm going to do is, before we were instancing cells inside, I can either draw in this cell, you know, I've got this new cell, I can draw in it, or I can also instance stuff. So now I'm going to instance, instead of, I'm just going to clean this up. Instead of instancing, you know, some drawn layout, which is what I showed you before, I am going to instance the programmable cell. And the programmable cell is different, as we saw. It has a little, you know, a little symbol on it, and I'm going to drag and drop it into my layout. And when I do, it brings up a little dialog, and it says, these are the parameters of this programmable cell. And this is a very simple cell. It just makes a box. So it's asking me, what is the length of my box? What is the width of my box? And you notice there is no units here, because the person that wrote this wrote it already in the units of microns. So 10.7 and 1.7 are in microns already. So I am going to go ahead and accept the defaults here. And now it's executing the macro, and voila, it made a box. So this macro, that's all it does. It makes a box on the metal 1 layer. And excuse me, but it does that according to the parameters that I requested. Just go back to the slide. So I did a new cell, I did cell instance, and I could either have dragged and dropped, which is what I did, or I could have gone to the cell instance, which would be cell instance. I could choose my little box here. And if I do the same thing, I get the same dialog. And I can even, you know, try different parameters. You know, maybe I wanted something like that. So now I've got a new box that's bigger or smaller, whatever I asked for, right? So I can instance from the cell instance, I can drag and drop from the design navigator, and it brings in the programmability of the box. So now, you know, I entered the values I wanted, and I clicked OK, and it put my box into the layout. Now, what happens if I decide I really don't like the size of that box? Well, I can edit that object just the way I edit any object. But so now I am editing it as a programmable object. So let's go back and do that. Okay, so now what I have to do is I have to select it, right? And it says instance blah 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 of cell my box. So now I go to edit object, and when I do that, it brings up the parameters that I asked for. So I could change this now if I decided it really wasn't wide enough. I could do that. So this is how you can work with programmable cells. And the reason why you need this is tomorrow in the design kit, we have programmable cells. And so you're going to have to learn how to use these programmable cells. I mean, you could design all of your layout without using programmability, but Priya has created a programmable JFET for you that you can use. And so if you want to hand draw all of your JFETs, you can do that. But if you use her JFET generator, it's going to, make it programmable for size and put all the geometry in the right place for you. I just showed you a simple thing, which just makes a box. But you can do so much more, right? You could make a circle. Any questions about instancing programmable boxes or programmable cells? Any questions? If you notice, we also have the array capability as well. So now I've just made an array of my boxes. And if I went in and edited that, I could give it a little space in the extraction. And I guess I have them overlapping a little bit. So anyway, any questions about this? Okay, so I showed you how to update the T cell, and then and this goes way back to the original question, when we were selecting things, someone asked me, what is it, why does, I can see the circles, but then what is this other stuff? So this gives you an idea of the design area. So I showed you the origin is marked with a little plus sign. The cell cell instance has the instance with its name shown. So when you select it, it shows you the name of the cell. When it's unselected, it just shows you the geometry. And then we saw the dots, which are the grid. And then you can see the other types of objects. And we're going to talk about wires and other objects later, and hopefully today, we'll see. Okay, and then I pretty much did the demo of the cells already, so I'm going to skip that. And the other thing I am going to show you is the is a demo of the Windows menu, and so that you can understand how ELEDIT utilizes Windows. Okay, so as you saw, the design navigator is a window. We have these little we had this design, which was my programmable cell. We also have some other stuff back here. And as you notice, as I click on the title bar, it's a little darker, so I know this is the one that's selected. So if I go over here to the design navigator, it knows that it's selected. So in ELEDIT, you have these different windows, but you also have tabs now. So for example, if I click on the tab, I'm going to be working with this one, or if I click on this one, it'll bring that window to the front. Here's the design navigator, and here was my resonator, which looks really trashy. So you can play with the tabs, you can move the individual windows around, and then there's a whole Windows menu. So I like to often cascade my windows so I can find them. Because I like my design navigator to be over here. So I often, put it over there so that I can easily drag and drop into my cells. And then I like to have them like that in a cascade. But you can tile them and, close them all except for the one you're working on. And then it shows you which one you're doing. I don't even know what theme does anymore. Oh, okay, yeah, you can change the theme of the way it represents the outer border of the cells. So any questions about the Windows menu or about cells? Because we're gonna now assume that that's all, you've got it, and we're gonna completely move on to other topics, because we're gonna talk about design kits and libraries now. Okay, well then let's move on. And we are going to go on to some new and interesting things. Okay. And we'll actually use a different design. Okay, so let's close this guy. And we will open the second PowerPoint. This is the longest one, but we do have quite a few things to talk about. Okay, so now we're going to talk about how to make a new design, because I have up until now showed you only designs that we made and files that already have stuff in them. But now when you're doing your own design, you need to know how to start a design and how to work with it. Okay, so we're going to learn how to start a new design, how to attach to a technology reference from a design kit, how to work with libraries, how to set up layers, and how to do some Boolean operations. We'll probably not do the setup layers and operations, Boolean operations, because we would probably leave that to more advanced class, because all of the layer setups and Booleans that you need to do are actually in the design kit. Okay, so let's talk about a new design. So to start a new design, you would go to the Edit File menu, because we did File Open before, but now we're going to do a new design. And there are two types of databases in Edit. One is the Tanner database, and this is most often used by MEMS, photonics, lots of people. And then there's Open Access, which is often used by people who need to operate with Cadence. Because Open Access is kind of an industry standard now for Mentor Synopsys and who's the third one? I forget. Yeah, Mentor Synopsys and Cadence. But Tanner has its own TDB. I like TDB because it's simpler to understand. But those of you who may be working with people from Cadence may occasionally want to create an open access database. Okay, so we have the open access database and the Tanner database, and you can choose, they kind of work interoperably, that if you have an Edit file, you'll be able to convert it to an open access file, or if you had an open access file, you can convert it to a Edit TDB file, and you can save them back and forth. So typically, the same user interface applies to the two formats. So the database really doesn't matter when you're drawing things in Edit, but just to keep it simple, I like to use TDB. And I think in this class, and also with the 3IT and CMC, TDB is, I asked Priya that you guys would mostly be using TDB and GDS2. Excuse me. And then when we're writing out our file formats, I make a distinction between a database, which is like Edit, where we have our layers, our colors, everything, our curves are curves. And then there's output formats like GDS2. There's one called Oasis. Many of you may be familiar with DXF from AutoCAD. There's SIF and there's Gerber. Gerber format's often used for making boards. And so Gerber format, we won't talk about Gerber or SIF or DXF or Oasis in this class. We're going to focus on GDS2. But, pretty much once you understand the concepts with GDS2, you can read the manual if you need to output to another format or take the advanced class. In the advanced class, we talk a lot about DXF. Okay, the other thing that's the only other difference between Oasis and Tanner is that when you are using a Tanner database file, you have a single database, and then it references a bunch of libraries, and those libraries are read-only. So you'll see when we make a reference to the library to the design kit, you will not be able to change the design kit. Only the CMC can if you use the TDB mode. So if you want to change a cell in the library, you're going to have to copy it into your private copy of your TDB. If you're using Oasis, it's a multi-user mode. where there are multiple libraries and everyone can edit. You can edit the design kit and someone else can, the CMC can, and it can be, you can create a lot of complexity. So that is the only difference between the two formats. And we're going to keep it simple since you guys are beginners, is the CMC is creating the design kit and you are using it by reference within a read-only mode, but we'll show you how to copy the cells, you know, if you really want to edit them. Whereas in the multi-user mode, you don't have to copy, you can just go right in there and change it, but be aware you're changing it for everyone else too. Okay, and then the other thing that happens is that we have these libraries that have cells in them, but then we also have what's called a technology. And a technology is the basis from which we're creating everything. So we have, in a technology, you have the GDS numbers, the layers, the colors, all of those things. So if you change, say, the color of a layer, then all the cells in the library get changed and all of your cells get changed. You'll see color changing everywhere. So the technology is kind of like the base layer, and then the cells use the technology to create the geometry. So now we'll actually go ahead and do this. We're going to set, we're going to do a new design. We're going to set the file name, and you can call it whatever you want. And I'll actually go and do this for you. So we're going to discuss the technology information now. So the technology information can be, you can set up your own, like if you're creating your own file and you're not using a design kit, or you can get the technology information from the design kit. And in this class, we're going to get all our layers and colors and GDS numbers from the design kit. Otherwise, you would have to set up all that stuff. And then, so these technology settings can be imported into other design files. So if you start a design and then tomorrow you want to have a second design, you can just import that information. And then for those of you, I don't think anyone's in this class, but I had some people that used ELEDIT 20 years ago. There was a file format called TTX that had all this information in it. So all of the technology information are like the layers, the units, the grids, the design rules, and a listing of the external libraries. And also for those IC designers, how we make vias. So in our, when we set up a new design, we're going to have a TDB file. And if we are going to have a technology reference, we have these choices. We can either have none, so we're starting from scratch. Maybe we're a PDK designer. We can also have a technology file that's compatible with Cadence, or we can have a TDB file that is the usual file format for our technology information. And so what we're going to do is we're going to, when we create our new design, we're going to choose the TDB. We're going to have a TDB technology reference. So we could mix and match. For example, you could say, hey, I want to make a new design, but I want to use a Cadence technology reference. So I could have a TDB file to store my data, and I have a Cadence technology reference because maybe the CMC only had a design kit that was created for Cadence. Excuse me. And then when you choose your technology reference, you can either do it as a one-time import, or you can make a link. So just like libraries can be linked, technologies can be linked. So if I have that link, that means that if Priya adds another layer or they change something in the design kit technology, you will see that change. So we recommend that you leave this box unchecked so that you will always have a link to the CMC technology file. Okay, so we're going to go ahead and do this, and we're going to create a new design, and we're going to see what happens when we have a technology reference and what happens when we don't. So the first example we're going to do is new design. We're going to choose the TDB file, and we're going to choose a technology reference as none. And we're going to click OK. So let's go do that and see what happens. So I will go over to my Edit. I'm going to close everything up, close all my other designs. I'm not going to save all that stuff that we did. So now I'm going to do File, New, Design. I'm going to choose a TDB file. I have so many test files, so we'll call it test 11. And now I'm going to choose a technology reference of none. So now I have a new file. And if you notice, I don't have any layers. I've got nothing, just a blank Edit. So that's not very interesting. So if I go to tools, I've got, no layers in my layer palette except for the default layers from Edit. I've got a completely blank design. And so one of the persons asked, early on, can I create my own stuff? And yes, in the advanced class, we show you how to, add a layer, you can add stuff. You can set the GDS numbers, you can do a bunch of stuff. So you can start from a completely blank Edit. But in this class, since you have the PDK, you're actually going to start with a technology reference from the PDK. So I'm going to close my design. So now we're going to see what happens when we have a technology reference. Okay, so I showed you that, Edit was blank when we had the new design. So if we had a, if we tried to do a new cell, we would have no layers. So now we're going to go back and we're going to do a technology reference. And we are going to choose a technology file so that we do have some colors. So now we do new, file, new, design. I'll call this test 12. And I'm going to set up a technology reference of TDB. And I am going to browse to, and if you want to follow me later or tomorrow or now even, you can go to the data for the class. And here is our tech file that I'm going to choose. And I'm going to open that. So now when I click OK, I can now go into my setup layers, and you'll see I've got a bunch of layers now. And if I go to cell new, I have a bunch of layers. So using the technology file, I'm bringing in information into Edit so that my Edit is no longer blank. It has information about the layers, the colors, the grids, and whatever I need to get started. So is that clear? Okay, so we showed now that if we use a technology file, you get your layers. Okay, so hopefully that's clear. If you have no technology, you get nothing. If you refer to a technology, then you can fill in that technology name. Okay, so now we're going to talk a little bit about how, suppose I did set up a blank file, and I would like to now add a technology. Okay, so in this case, that's called technology referencing. So under the setup menu, we have some options, and this gets at the question that was asked by, I'm sorry, I don't remember whose the name it was. Maybe you guys should say your name before you ask your question. She said, hey, I have this technology, but what happens if I want to change to different fab? You can now remap the technology that you have to a different one. So now we will look at those options. Now, we in general will not need to do this in, if you do everything the way we're asking you to do it tomorrow with the design kit, but you could get into trouble, or you could forget, or whatever it is. And so I'll show you this method as well. So suppose I had a blank, I have no technology mapping. So I'll do a new design and I'll have none. Yeah, okay, overwrite the file. So now I can go into setup technology reference. And you see, I can now have different choices of technology reference, just like the way that I did before. So I can set up a technology reference to TDB, or I could use Virtuoso, which is cadence, and I can also just have none. So if you have started your design and you forgot to set the technology reference, then you can just set one there under the setup menu. Now, if I have a technology, I can also import a different technology. So I can click on the import technology button and I get this option. So here I can choose the type of technology, which is TDB, and it asks me for a file, and I can then selectively bring in just what I want. So for example, what the other lady was asking about is I could replace my layers, or I could merge them with the layers I already have. And I can do things like, maybe I want to uncheck all, and because I'm happy with my layers, but I just want to bring in some DRC rules, because maybe Priya said, hey, we've added a couple more DRC rules, everything else is the same. We can just bring in what we need, okay? And so that is a way to import parts of a technology, or all of it, depends on you, okay? So we can, with this, we can do a technology reference, we can import the technology, and we can also export the technology. So if you want to export from Tanner to Cadence, you can export your technology and then use it with Cadence, okay? So here is the details of that. We talked about it. We did set up technology reference, just like we did before. We can do the, if we choose the Virtuoso, we will get, these are Virtuoso files, the tech and display file that we can bring in. And again, these are for your reference, these notes, because, we're going to do TDB in this class, but if you say, hey, I've got to bring in a cadence file, this is how you do it, you can refer back to these notes. And so typically we would do TDB, and we would set the TDB file here. If we did the import technology, we have some choices. So let's talk about those. When we do our import technology, we could import info from Virtuoso, which uses tech and display files. We talked about TDB. And this gets to the answer of this person's questions that we had a long time ago, was we can import a GDS layer map that, like if we had Fab A and Fab B and they had the same layers but different GDS numbers, this is where you could just import the GDS layer map for Foundry B. So suppose I had Foundry A that had polysilicon, metal 2, whatever. And then Foundry B that had polysilicon, metal 2, whatever. But they had different GDS numbers. I could read that layer map in and replace the GDS numbers that I had for Fab A with those for Fab B. Does that make sense? Okay. A lot of this stuff also, once it's kind of hard, like in a one-day class, to kind of get all of it into your brain. So once you start using it, we'll see tomorrow even, we'll go over some of the similar concepts and you'll get used to it. But it's a lot kind of a lot to absorb. And there's lots of stuff I'm not even going to show you either. Okay, so we talked about this slide is that this is the technology import that we can replace or merge the layers. We can also we can also bring in different technology information about colors and the grid, things like that. So this is a good reference slide for you that you know, you can use later when you say you want to bring in some design rules, or you want to make sure your grid is the same grid that the CMC is using. You can do a technology import once the design is already set. And then, as I said, you can export your technology as well. So we can export the technology to Cadence, and that they use a technology file and a display file. Okay, so we're going to talk about libraries now. And
Yeah,
it mutes me too. Okay, no worries. So the way libraries work is that under setup design, before we had the libraries that we could set up, but I'm sorry, the technologies that we could set up, but now we're going to set up a link to libraries. As I mentioned in the PDK that we're going to talk about tomorrow, the CMC has put the technology and the libraries in a single file, but we don't always have that to be the case. But I will show you how to do the general thing, which is to have both a tech file and a library. So if we go under Setup Design, we have a tab called the Libraries tab. And the path entry sets the path to a given library. And we can also give a name to our library because we may have multiple libraries. And this is true, like, for example, we might have, in the IC world, we might have a pad library, a high voltage pad library, you know, maybe we have some standard cells. We could have a whole bunch of libraries. And as we discussed, we can, when we're bringing in the library as a library cell, we cannot edit it. And this is what I was talking about earlier, that if you opened it with file open with the name of the library file, you could edit it. But when you bring it in as a library file, you can't edit any of the cells in it. And this is for your protection. And so you can instance them, you can view them, but you cannot, you can't change them unless you separately file open, edit them. And we'll take a look at that when we instance some cells out of the library. So let's see, why can we not move on to the next slide? Let's try, oops, my whole computer is frozen. Oh, there we go. Okay, so in the, let's look at the design library setup. In that setup, which we'll actually do live in a minute, we can add a new library, we can remove a library, and we can also move the libraries up and down. And the reason why we have to have an order to our libraries is that what happens if Priya designed a library that had a cell called pad, and someone else designed a library also calling their cell pad. Depending upon the order in which the libraries are listed,Ledit will call the appropriate pad cell, because since these are separate files, they could very well have the same cell names. So if you wantLedit to choose a particular order, then you need to make sure that you specify that order in the library list. We also have what's called a library navigator. Now, the library navigator kind of looks like the design navigator, but it's different in the following ways. That when we look at the design navigator shows us the cells that are in our design. And those cells could come from one or more libraries, and they could be our cells and whatnot. But the library navigator allows you to open a library and see all the cells that are inside of it. So that's kind of the difference, that it's for navigating the contents of a library. And so you then specify the library that you want to look at if you have more than one listed, and then it will give you a listing of those library cells. And so you can see kind of what's inside there. So this is the, you know, if you have more than one design open, each design could have more than one libraries listed. And then this is the cells of the currently selected library. And they're highlighted whether they are, you know, they're different cases of the library lists. So they could be, you know, things that are hidden, or because you can hide a cell so nobody can see it, modified. So there's various states that a cell can be in. And then you can also look at them in various ways, like the top level, or you can look at them bottom up, and you know, check them out according to different hierarchies. So we're going to do an example. And so I'm going to start by making, since we closed all our designs and stuff, since we were messing around, I'll make a new design and make sure that we have our appropriate design. And then we're going to pull in and make a library. Okay, and you can do this too if you like, but the first thing we'll have to do is reset up our, in fact, I think I even closed edit. So let's go here, start edit. And if you want to follow along with me, maybe, you know, make sure you have all your other designs closed so that we don't, you know, accidentally look at the wrong design. So I'm going to do a new design. And I will put this on my favorite place on my desktop. And let's go with test 13 again. Let's make it test, yeah. Okay, and then I am going to load a tech file from the day one training. And this is a tech file that is consistent with the library that I'm going to use. And so we talked about that you know, in order for the library's cells to be able to be displayed in edit, you have to make sure that the library cells have the same layers and GDS numbers and all the stuff, like, not GDS number, but layers that are used in the tech file. So you always have to make sure your library and your tech file are at least consistent, because you could have a library that uses only a subset of your technology layers. So maybe you had multiple technologies that you merge, but you at least have to make sure that every layer that is used by the library cell is defined in the technology. So that's how those two are related. And in the case of the CMC, since we're using the same file, that will happen automatically. Okay, it's going to ask me if I want to overwrite this out. Yeah, okay. So now let's go and take a look at the libraries. So I'm going to go into Setup Design, and I can see my technology was brought in. So I have my mumps technology, and now I'm going to bring in a library. So again, this is a little, you know, it looks kind of blank, but if you click on the path, then the little dots will start open for you, and you'll be able to browse. So in the data for class directory, I have something called lib.tdb, and I will click on it to open it. And then you can give your libraries a name. And if you don't feel like typing in a name, if you just click, it will invent something based on the name of the TDB file. But I could call this, you know, lib.mam or whatever I want to call it. That's my library. And then if I use this button, I could add a new library, but in this case, we're just going to have one. Okay, so now we have added a library to our design. So let's go look at the slides to follow up with them. So now we have browsed and we've created our library. So now I will look at the design navigator, and we'll see what there is in this library and what's in our design. So we are going to make a new cell so that we have something in our design, and then we'll pull up the design navigator and we'll see what was in this library that we brought in. Okay, so I'll do a cell new. So I've got my cell 1 there, and then I'm going to do my design navigator. Okay, and I like to arrange things and make them nice and clean. And so I'm going to move my design over here. So this is my design, and now we can see what's in the design navigator. So I have this empty cell that I created, and then I also have this blue, listed blue library. And if I see what's in there, I have 2 cells, a comb drive and a spring. So now I can instance these cells and use them in my design. So I can drag and drop, just like I could drag and drop from the cells that are in my design. But then I can also, I can also open them. You can open a file. Oh, okay. If you can't open necessarily to open the library file to edit it, but you'll be able to view the contents of it when you instance it. But if you go to select it, you can make an array of the library cells, but you won't be able to go inside and change the library cell contents in the way that you can with the cell that you just drew. And if you see here now, this library cell has been implemented into our cell. So that's how it works, that you now have access to, and this is what we'll see tomorrow, when we create the JFET, when we attach to the JFET library and the JFET design kit technology file, we will then have a bunch of cells that we can use in our design. Okay, so these are just like when you instance them, you can use them in the same way that you would have in the regular design. You just can't edit them, and they are labeled blue to remind you of this fact. Okay, so that's what we did there. And so now we can just, as I said, we can drag and drop, or you can also, if you want, you can do a cell, you can do a cell instance out of the library. So here I am pulling up the libmam library, or when I do a cell instance, it's going to ask me, do I want to instance a cell from my own design, or do I want to instance a cell from the library? So it will, if you have multiple libraries in the dropdown, it will ask you, where do you want to instance your cell from? From the design navigator, it's obvious because here I have my design and here I have the library. Okay, so you, as I said, you cannot edit these cells, but you could do a file, open, and then browse to the location of the library, and you could open it and you could edit it. But you cannot edit it from the design navigator the way you can edit a regular cell in Edit, because it's incorporated by reference. Okay, hopefully that will clear up any confusion about whether I can edit cells, I can't edit them, how do libraries work. I think we're done with this section, and let's see. Okay, so we have till, Priya, remind me again, we have till 3, right? Or 6 your time, correct?
Yes.
Okay, all right. So what I've given you also is a bunch of reference slides at the end of this PDF. And I'm not going to go through them because even though I think they're important, I think that, they're boring to talk about in just a class like this. So you can just read them on your own, and it should help you, you know, if you want some more details. So now I am going to switch to our third section, and we're going to talk about some other stuff, some actually easier to explain stuff. We are going to talk about some more advanced ELEDIT features. And I am going to give you, at the end of the day tomorrow in your Dropbox, you will have some exercises that will lead you through both practicing drawing basic layout, working with cells, and then you will also have an assignment that it's going to lead you through, excuse me, all of the stuff I'm going to talk about right now. So if you want to, you know, practice the stuff that I'm talking about, you will have an opportunity to do so in the in the homework. You know, normally when we do a live class, Priya and I would have a, you know, you would actually do it right now, you know, with your copies of ELEDIT, and we would walk around the room. So I'm really looking forward to when we can do that, because it's really helpful, I think, rather than listening to me, for you guys to really do this stuff. But I'm the best you got, so we'll have to do it. So we're going to talk about Boolean operations. We're going to talk about what are called base points. We're going to talk about object snapping, and we're going to talk about alignment functions. This will be a short section, but we should be good on that one. So let's see. First thing I want to talk about is Boolean operations, because this is really helpful, and we will, you know, this will help in a number of layout operations. So what you can do is select different objects, and then you will be able to operate on them together. So for example, if you would like to take this blue object and this orange object and create a new polygon that is the merge of those two, or the OR operation, you can select them, and then you can go into the Boolean, under the draw menu, there's something called the Boolean grow and Boolean operations. And you can operate on the different polygons that you choose. So you can do this on multiple selections. Typically you would do them on like just 2, but you can have, you know, you could select 5 polygons and create the OR of of all 5 of them. You could also use this to grow or shrink a polygon if you have, or a set of polygons. So the operations that you can do on the polygons are specified here. So we have a result layer. So for example, here I have a blue polygon and orange polygon, but the result is going to be a gray polygon. I have an operation that I do, and then I also have the inputs that I'm going to do. And I can either delete the inputs, or I can keep them around. So depending upon what you want to do, like for example, if you had one polygon and you wanted to cut a hole out of another polygon, that would be a minus operation. You might want to just delete the 2 input polygons and use the output polygon. So we'll take a look at this in detail. So we have the result layer. We have the operation to be performed. So, and the inputs. So we can do an and, an or, and one of the ones that's really nice that is an XOR operation. We can take the not, we can grow, we can shrink, and we can subtract one from another. So this is a really good way to subtract if you have to create holes in layers. You take one poly, you can draw the hole, draw the other polygon, and then just cut one thing out from another. And so it's a pretty helpful operation. And then, as I said, you can delete the inputs or you can keep them around. And you can also put the result of the operation back onto the same layer if you want to. Like, for example, in this one, they have the input was 2 boxes on metal, and they put the result back on the metal layer. So these, this is actually a new, for those of you who used ELEDIT a long time ago, this is a new function in ELEDIT in the last couple of years. Because you used to be able to do this on layers, but not on objects. Okay, so any question about the Boolean operations? I can do a demo if someone likes, or I can just move on. Any questions? Okay, I'm gonna, oh, well, somebody said something.
They want a demo.
Oh, they want a demo? Okay, sounds good. Let's do a demo. We like demos, keeps us awake. Okay, having trouble. Okay, there we go, it's just slow. All right, so let's do cell new. Okay, so if I have, I'm going to be real boring. I'm just going to have a red square. And I will have an orange square. And I am then going to go under the draw menu. And I'm going to do the Boolean Boolean thing here. So you have to select, in order to hit OK, you have to select your polygons. And so I am going to, in this case, I'm probably going to do a subtract. So one of the things that you want to notice is, you know, what is A and what is B. So the first polygon you select is A, and the second polygon you select is B. So we'll take a look at this. So I'm going to select the big polygon first. I'm using a shift key, and I'm going to select the second polygon. So now when I go into my Boolean grow operations, you can see I have 1 box on poly 0, 1 box on poly 1, and I'm going to do a subtract. And I'm going to say I want my result to be on, let's put this on the metal layer. Okay. So now I will, and I'm going to go ahead and delete the inputs after the operation is done. So now I have created a polygon on the metal layer that took my box on poly 0 and subtracted the box on poly 1 and shoved it on the metal layer. Now, this was kind of trivial because I just did it with a box, but if you had some weird arbitrary polygons, it could be, you know, very helpful to be able to do this. And think about doing it as an array, right? You can have multiple objects and subtract a group of objects from another object. Okay, was that a good enough demo? We're good? Okay. And as I said, the exercise that you're going to do, if you choose to do the exercises, will also exercise this with a more complicated and good example. Okay, so now we're going to talk about the concept of base points. So the interesting thing about ELEDIT is the operations that it does, like rotating and flipping and things like that, are typically related to or referenced to the edge of the object. But what happens if you wanted to rotate about a different point, or flip or mirror about an axis that's not on the object? Well, ELEDIT has added these things called base points that allow you to do this. And this was something that they, you know, took from AutoCAD, because a lot of AutoCAD users like this function. So to turn on base points, you want to make sure that they are turned on, because by default, a lot of these advanced features are not either turned on or they are even hidden, because, you know, there's a lot of lot of functions in Edit, so they don't want to turn them all on. So if you go into view toolbars, that's why I showed you the view toolbars. So if you want to turn on base points, make sure that the base point toolbar is active or present. And if it's not, we'll turn it on with view toolbars. So we'll go in there and check it out. And then you want to turn on the use of base points by clicking on its little icon. And then we have to set the coordinates of the base point. And where is the point about which we're going to make that reference? So we can either type it in or we can specify it with this little yellow, pressing on the little yellow icon. And what happens then is Edit will then add a little marker. I don't know if you can see this on my screen, but there is a marker that gets added to your layout. And now when we do any operations like rotations and flips and stuff like that, it's going to be about that base point. So that's really helpful, especially for people who are doing polar arrays or whatnot. So there are different cases that are then that then can be used. For example, when you make an instance, we can make sure then that the instance is placed at the base point. So this is really helpful. Remember when we did instancing, it just slammed that instance in the middle of your screen? Well, now the instance can be placed at the base point. So if you want to make sure that whenever you're instancing a cell, it goes where you want it to go, then you can use a base point to put it there. And also the other helpful thing about base points is if you are copying and pasting, if you just do a copy and paste in Edit, it puts the pasted object at an arbitrary location. But if you want to make sure that when you cut and you paste, you place the objects at at the location where you want them to be, you can use a base point for that. So you can set the base point for the source reference and then do your Control-C and then place the base point at where you want to make sure that corner is placed and then do Control-V. So this is a good way to be able to cut and paste very precisely. Moves can also be done using base points. And this is really a kind of a critical feature because a lot of times when you're moving, you kind of pick up your object and you move it and you're not sure where it's going, right? You have to try to line it up, you use your grid, you do stuff like that. But if you use a base point, it's very clear where that point, where that object is going to be moved to. So you can select the object where you want to move, set the base point where you want to put it, and then you just do the move normally with your middle mouse button, and it will make sure that the move is executed according to the base point. And also editing, we can make sure that when we select an edge, we can make sure that the edit, when we edit an edge arbitrarily, we can make sure that we're editing it so that it exactly goes where we want. Like for example, in this picture here, the blue polygon is being edited so it just fits in the right place in the red polygon. And sometimes, if you're sitting there and you're trying to line things up, it can take a while. But if you have a base point, it's extremely easy to specify where you want things to go. Same thing about rotation. I think this is where base points really shine, is that you can specify the axis of rotation or flip. Like if you flipped this polygon on the left, it would just flip right about the edge of the polygon. But here we've placed a base point in between, so the flip happened relative to the base point. And same thing with rotation. The center of the rotation that's being done with these two polygons is being set here with the base point. Okay, any questions about base points? As I said, the exercise that you're going to get today will be, well, actually, we'll probably give it to you tomorrow so that you'll be able to do it, at your leisure. Then we'll also use base points. Okay, so let's talk about object snapping. So, oh yeah, I do want to show you where the base point. I don't know why I can't get out of this PowerPoint. There we go. I do want to show you where the base point menu is and what it looks like. So if you do not have it on, we would go into the view toolbars. And if you see my base point toolbar is not being shown. So I got to click on it. And now I have my base points. So this is saying that I want to use a base point. This is saying that I want to place my base point. And so, you know, you may have the case that you're doing a bunch of base point work, but then you're done with that. You want to go and turn your base points off. And from then on, LEDit will act normally. But when you're drawing, when you're using the base points, you just click it on and all the operations will use the base point. Okay. So let me go on to the next one. We'll talk about object snapping. So again, this is an optional toolbar. So you turn on object snapping by clicking on its little icon that looks like a magnet. And when you do that, now LEdit will allow you to snap to different object locations. Because before, when you were editing things with LEdit, all you got was you could move kind of the interior of the object and you could edit the edges. But now with object snapping, you're going to be able to address different parts of your object depending upon what mode you're snapping into. And this is really helpful because, like, for example, if you're using, especially when you're using it with base points, that if you want to snap a corner of an object to a particular place, you would select corner snapping or vertex snapping. So there are a variety of modes that you can have it in. So let me show you that. Here are the different snap modes. We can snap to a vertex. We can snap to a midpoint. We can snap to an edge, an intersection. You know, the different, the center of a wire, the quadrant, you know, the quarter of an object. And we can also snap to the instances themselves, the edge of the instance, a pin I won't talk about because that's part of the advanced class, and also the instance, the surrounding of the instances, what's called a minimum bounding box if your instance is not a square or a rectangle. So you can snap to more than one thing at the same time. So you can enable midpoint snapping and vertex snapping if you want. So you can do that. So as I said, we can set up the snapping modes through a setup, and you can change the way that instances are snapped using this part of the object snap setup. And any questions about snapping. And again, our example homework assignment that you'll do, you will exercise using snapping. Okay, so another function that I wanted to make you aware of in LEdit is the alignment functions. And I think maybe Cadence has this too, I'm not sure, but the alignment toolbar is also another optional toolbar in LEdit that may or may not be turned on. So you have to go into the view toolbars. And in this case, you have a bunch of different choices about you know, how this tool works. So you just click on the one that you want. And so typically you select your objects and then you choose what you want to do. So I can align all my objects to the left or to the center or to the right. I can align them vertically, top, center, bottom. And so to enable the function, a lot of people, try to click on the icon first. The way this toolbar works is it's grayed out. So you have to select your object first, and then the toolbar will light up. I often make that mistake. So select your objects first and then choose what you want to do. So in the next slides, I wanted to also show you what's going on with the other options. We can just use the alignment to distribute objects. So we can distribute them horizontally, vertically, and this is different than lining them up. So distributions allow you to set a spacing. And we can also tile in them horizontally and vertically, and also as a 2D array. So what does this mean? This is helpful for things that are not necessarily just boxes, okay? But we want to line them up, we want to line up edges of things. So again, we have this concept of a minimum bounding box. And so I'll explain that with some pictures here. So for example, if I wanted to take these objects that are kind of, different sizes and align them on the left, I have to figure out what does left mean? So ELEDIT has this concept of a minimum bounding box where it finds the maximum edge on each, of the four sides, and that's the minimum bounding box. So if I say align left, it's going to align all the objects to the minimum, whatever it found as the left edge. Okay. So, you can use this to align objects of various sizes on a given side. And so, for example, if you're aligning left, you could align to to this polygon. You could have aligned to the edge of this one or the edge of that one. So ELEDIT uses the last selected object as the thing that it aligns to. Okay, so that's what it does when it does the left align on the polygon, this red one that was selected last. So for example, align horizontal center will do something like that, and align right will do something like that. The other thing that we can do, as I mentioned, is distribute. And so in this case, we take the minimum bounding box again, and we can distribute our objects evenly according to some distance function. So when you do the distribution, it's going to ask you some questions, like what distance would you like between the objects when you distribute them? And so this little dialog comes up to help you do that. So these are all kind of more advanced ELEDIT functions than just pushing the polygons around by hand. This would be a distribute vertically, for example. And then here is, we can take a bunch of selected objects and tile them into a 2D array. Okay, so it's doing something, fairly sophisticated. These objects were not obviously in an array, and ELEDIT does its best to find out, figure out what you meant by, the rows and columns, right? And it has a little algorithm for doing that. As I said, it's useful for non-simple arrays because these particular objects are on different layers, they're different sizes, and ELEDIT, figures it out. Any questions about those additional commands in ELEDIT? Anything you saw? I mean, I think these slides are pretty straightforward. I told you that the libraries and the technology files was the hard part, and the rest of this is much more simple. But this is kind of stuff that's been added to ELEDIT that hopefully will help you. You know, you may not right now think about how you're going to use this stuff, but after you do the exercise, you'll see how we used it in designing an RF switch. And you'll probably figure out, you know, think in your mind tomorrow, you know, I bet Priya's thinking, oh, I bet I could use some of these functions when she was laying out all those JFETs, right, Priya?
Yes, very much.
Yep. So moving on. Okay, so we have a little bit of time before our break. So let me move on to.
Do we want to do something like DRC and then go back, or?
Up to you. We could do DRC and then go back if you want. Sure. I did want to hit wires though. You know, because normally even those people who are going to be in the class tomorrow can learn about DRC, and we could even do that tomorrow. That's why I wanted to talk to you about what topics you want to do. Would you prefer I did DRC now and then the other stuff?
No, you're right. I think wires are important too. Yeah, let's
yeah, it's hard to choose, isn't it? But I think for those people who are just learning the ELEDIT drawing basics, they could, you know, if they're not coming tomorrow, they can skip the DRC and we'll do the DRC tomorrow. But you know, probably good to give them when we can give people the choice, right before we end for the day. We'll do that. How much time do we have? It's 1:25, or sorry, 4:25. So we have another hour and a half?
Yes.
Okay, we might get through it. We'll see. And then we can give people a choice of what we want to do, right? Okay. But, you know, it's more for you guys. So, you know, Priya, you tell me. I'll talk about anything.
No, I think wires are important. Yeah, let's start with this.
Yeah, I cut down even this section on advanced to fit in the one day. All right, so we'll do a couple things here and then we'll take our break and then we'll try to sneak in DRC by the end of the day. Okay, so we're going to talk about tips and useful commands. We'll talk about how to find things, how to make rulers, curves, wires, a few macros, and I moved all the cell operations into the reference. So we're probably good to go, Priya. Okay, some useful tips. If you are drawing in a particular mode, you're going along and drawing in 90-degree mode, you can shift by using the control key, you can shift to 45, and shift plus control will change all angle drawing. You can also check if you're drawing on a particular layer, the layer where an object is drawn can be selected by hovering over that object and pressing the A key. And then the other thing that is helpful is that if you have, if you have different types of objects in your design and you would like to hide them, like for example, if you don't want to see the instances, you just want to see the geometry in your design, you can turn off the display of any type of object by going into the drawing toolbar and right-clicking on that object type and then just saying that you want to show or hide it. And that's just the way you do it in the layer palette too. So you can show or hide objects or instances. The other thing that might be helpful to you, and maybe in the JFET it's not so important, but in a lot of other things it is. In MEMS, we have things that are micron size, and nano people or photonics might have, stuff that they're working on at the nanometer level, but then you also have pads. Probing pads are hundreds of microns. So you can use multiple grids in ELEDIT so that when you're working at a very high level, you're on one grid, and then you can, switch and then work at a very fine level when you're doing other operations. So there's a whole toolbar for that called the multi-grid toolbar, and you'll be able to access that also by turning it on. It's the multi-grid toolbar. Then we also have the ability to move an object by a certain amount. So if we want to make sure that we are, really lining up, we can use the alignment toolbar, but we can also do this on an object by object basis by setting a position relative to another position. So for example, you can put, make a base point and then move an object with a vector off of that base point. And so this move by command is also something you should check out. So now let's talk about, the find command, because, just like in Word, or Excel, right? Every Windows program has a find command. And sometimes you need to, look for certain things in your design. So for example, suppose we decided that we wanted to find all the boxes or polygons on the metal 1 layer. You can set the layer where you want to find something, and you can select what you're looking for. And then you can then, just like a regular find program, you do find or find next. And then LEdit will zoom and pan depending upon how you set the options, and then it will display them. Now, why is this useful? One of the things that I found it was really useful for is that when I have very small objects and I can't see them, like, sometimes vias can be very small, but, maybe I have my metal or whatever it is, I've found this a lot in designs, that you have these really small objects that you can't see and you don't know where they are, and you try zooming. And if you do the find command, you can, zoom and pan and locate the objects for you. So I often find that when I'm working with very small objects, that the find command is very useful. Or I'm just, I need to change a bunch of stuff and I just want to find all the objects on a given layer. The other thing that there is now a command in LEdit that you can find in a hierarchy, because the LEdit find function just works on whatever cell levels on the screen. And the find in hierarchy will actually go all the way down through the hierarchy. I won't bore you with this, the rest of the slide, because you can probably read it, but it's the same idea, same concept. So I'll go ahead and move on to the next thing. So now let's also talk about rulers. Rulers are very useful for especially for publications. If you are going to, want to show your layout or make a publication and show your design, you often want to show some measurements on the design itself, either to check whether you did something correctly or just to annotate and indicate a dimension. And LEdit has 2 types of rulers. One is called a persistent ruler, which means that it's used for annotation and it will, stick around on the design. And the other one is what we call a transient ruler. So we'll talk about that in a minute. But the rulers can be orthogonal, 45, or all angle. And here I've shown an orthogonal ruler. And once you've put all your rulers down on your layout, you can clear them by using the clear persistent rulers command. So you can use this to draw nice rulers and indications on your layout, and you can be assured that these are not fabricatable objects. So you don't have to worry, this is not going on your mask. They are just used for annotation purposes, okay? And the properties of these rulers can be changed by using the Control E, because these are just objects. So the text size, usually when you make a ruler, the text size is never right. You can change the style of the tick marks, how the ruler looks. And also, you know, if you want to set the starting point and ending point by hand, you can do that, or typically just draw it, right? So, and the rulers don't have to be, you know, as I said, orthogonal. You know, you might have an all angle distance that you're trying to indicate by drawing an all angle ruler. Okay. And I'll finish temporary rulers and then I'll give you a break. So temporary rulers are used for a different purpose. They're more for measurement. Okay, so the persistent rulers are used for display. You want to show how many tick marks and what the distance is between A and B. But temporary rulers are used more for measurements. Like if you want to check, you know, the distance between something, but you're not looking to have that ruler stay around. You can use what's called a temporary ruler, and then the measurement distances that are displayed are set in display units. And display units are set in the setup design technology. And as we talked about, you know, in our case, they're microns, right? And so you use the T key to start a ruler, and then you press the T key to end it. So here, for example, you know, I have, this is just a temporary ruler where, you know, we've clicked here, and then it will display the distance. And it's really not, you know, it's not intended for annotation. And then it's expected that you will clear that ruler once you're done with the with what you're doing. So the way this ruler works is that you don't decide whether you want an all angle or whatever it is. It just picks up the drawing mode. So if you're drawing in 90-degree mode, it will stick to 90-degree mode. If you're drawing in all angle mode, it will allow you to measure all angle distances. But excuse me, if you are in 90-degree mode of drawing, it will not allow you to you know, measure all angle. Okay, so you can use the shift control and control shift key to change that drawing mode. And the rulers are cleared with this little thing, to me that looks like a cigarette, but I think it's supposed to be an eraser. And then you can hide them with, I don't know what that looks like, a light bulb or something. Anyway, you can hide the rulers or clear them, make them go away with those two little functions. Okay, enough about rulers. So now we're going to talk about advanced curves. So if you have, and this gets way back, I don't know if you remember, way back into the question, someone said, hey, I don't believe that circle is a circle. It looks like a polygon to me. So we're going to talk about that right now. So we can take any object edge and convert it to a curve. And the reason why you might want to do that is if you want to add fillets, if you're doing some sort of, you know, maybe something in biology where you need a rounded profile of an edge. So you can take any edge and then you can then stretch it out to have a curve. And so you select the polygon that you want to do this to, then you select the edge where you want to curve. And so that's where this edge snapping that I showed you earlier, you know, the object snapping toolbar helps. And then you use the control key with the right mouse button to select that edge, and it will create a curve. Because in the ELEDIT native curves, you only have circles, you have toruses and pi wedges. But this allows you to curve any edge with a given, you know, a given amount of curvature. It doesn't have to be a profile of the circle, right? You don't have to slice and dice circles. So this allows you to just curve, you know, curve an edge. So it basically creates an arc, and you can drag your cursor to increase or decrease the curvature of that arc. And it can be concave or convex. So let's take a look at that. So for example, here, you might be filleting, so you want some rounded edges, but then you also might want to cut out, like make a little neck to have some concave vertices. And the way that ELEDIT measures that curve is that here I've created a negative distance of curve height. ELEDIT takes the edge that you indicated, and it either cuts out a bit of the curve or it extends that edge into a curve. And the curve height is measured in the center of in the center of that chord that's the edge. And then this is how the height is determined. So for example, this is a negative height going into the chord, and this is a positive height coming out of the chord. And that allows you to create things like bubbles and, as I said, concave vertices and all kinds of good stuff. So this is something that not a lot of people know about ELEDIT, because there's no toolbar for it. You just have to know about it, right? And the other thing that's helpful is that these curves work hand in hand with what's called the convert menu. So we can convert from different object types into others. So we can snap to the manufacturing grid. We can change the layer of all the objects on on one layer to another. We can also change a polygon into an all angle polygon. We can, if we have curves, we can remove them. So if you had a curved polygon and you didn't like it, you can remove that curve. And then we can also divide polygons if they have a large number of vertices into polygons with smaller number of vertices. Now, GDS, the original definition of GDS, only allowed polygons with 200 vertices. Most modern mask makers allow you to have much more than that. So for example, if I have a giant polygon where I cut out many, many holes, I could end up with, thousands of vertices. And if you have you're working with a very old mask shop, they may not accept your GDS2. So you can fracture your polygons, and so that they only have 200 vertices or less. So that's what the fracturing polygon is used for. If you're using, pretty much any modern fab, this shouldn't be a problem. So Priya, do you know where's the 3IT getting their masks made, or is GDS2 okay with more than 200?
I'm not sure about that.
Yeah, I don't think you're going to have a problem. I mean, you guys are doing JFETs, right? But in MEMS, we, like in our big microphones, we have thousands of holes. And so we can have, many, many thousands of points on polygons. So I don't think this is a problem for you, but if it is a problem, you can fracture your polygons. But most mask makers, even though the original official definition of GDS2 says no more than 200, it's not a problem. Was there something in the chat?
Yes, it is asking for a demo.
Oh, okay, sure. Okay, when I get to that part, I will do it. It's a little tricky, and that's why I didn't do a demo right away, because you can't see my fingers and you can't see what I'm doing. But I will try to do a demo for you, because or better yet, we can show you what you might be doing wrong, because if you don't do the control key, let's go back to where we were. It won't curve the edge. You have to remember to hold the control key down. So when I get to that, I'll do a demo for you. Sure. Okay, now my thing is frozen. Okay. So we can also convert polygons that might have all angle edges into orthogonal polygons or 45-degree polygons. And this could be helpful for doing design rule checking, because sometimes the design rule checker, if you have an all angle edge, will get a false error. But this is available to you. so you can make sure that your polygons that might have edges that are not straight, you can straighten them up. Okay, so there's also a tool in ELEDIT that automatically does fillets and chamfers for you. And that is, it can also apply to wires and polygons. And so you can draw, these all angle edges, but curved edges, but you can also have ELEDIT do it for you. So a chamfer, it'll put an all angle edge, and a fillet it'll add a curve. And so we can show you that tool. So it allows you to select whether you're doing the chamfer or fillet. It is going to allow you to do it on a vertex by vertex basis. And then, you can decide, which, whether you're doing convex or concave vertices, and then what the distance is that you're using for the chamfer or the fillet. And this is a command that you can find under the, there's some special all angle and curved macros that I'll indicate to you when we're done with the slide. I'll show you where to access them in the ELEDIT interface. And then sometimes if an edge is very small, it can't be chamfered or filleted. So ELEDIT will mark them and tell you if it cannot do the chamfer or fillet. And so how ELEDIT calculates this, and this is a slide that, you can forget if you're not doing any chamfers or fillets, but if you are, this shows you exactly what ELEDIT is doing. It's going to go and find, if you ask for a fillet, it's going to circumscribe a circle on the corners and then round that edge. And if you're going the other way, it'll circumscribe a circle and then remove that edge. And then you've got the one going on here. So this complex polygon has had a lot of things done with it. And then the edge A, the vertex A, is the place where the edge intersects the radius of the circle. So if you're wondering what ELEDIT exactly did mathematically to your polygon, you can see, and that's why some vertices may not be able to be filleted, because if here, for example, the vertex points can get so small that ELEDIT just can't do it, right? So yeah, this is some restrictions. Okay, so now I'm going to do some demos of curves and various merges and things like that, so you can get the hang of it, okay? And also see the value of some of these things. Okay, so I'm going to go into ELEDIT, and I will, first of all, I'm going to make a box. Let's go make a box. Okay, and then I'm going to go ahead and add a circle. Okay, so in ELEDIT now, this is a, these are two independent objects. I have a rectangle and I have a circle, and I have to move them around independently. So if I go in there and I select them and I merge them, let's see if I can move this. I don't know if I can move this. Okay. Now I can go in and merge them. So now they're all one object, right? So I can move this around. But if you see, I've now created an all angle polygon that has 39 vertices. So the rounded part of this polygon is, it's got a lot of vertices. But now if I draw and I do convert to curved polygon, you'll notice I now have an object that has 4 vertices, because now this edge is now being represented with a curve. So let's go ahead and take a look at that. you can see that there are 4 vertices, and between this edge, Edit has placed a curve with a particular curve height. And so I can change that curve height if I want. And then that will change the, the amount of curvature that's been added to that particular edge. So the benefits of using these curves are that your objects are much easier to edit. When that was a polygon, if I converted that to polygon, convert, now I have 19 vertices and I got to go in there and edit them individually. And who knows which vertex is on the curvature, right? So if you are doing any sort of curves, you really need to pay attention to how you're representing the data. And if we zoom in a bit, when Edit converted that curve, it snapped it to the manufacturing grid. And that's why having a manufacturing grid, choosing your manufacturing grid carefully is important. So let's see. I'm just trying to move this thing. Maybe I just have to move my Edit. So let's convert this back. Okay, so now I've got my curve again. But now if we go into setup design and I change my technology and I change this here. Now when I do my, convert to polygon, I've got a lot more resolution. I've got more vertices because when I did the object snap, I was able to, I had more, my manufacturing grid was finer. So I have a much nicer, circle there. So depending upon your purposes, the manufacturing grid is being used various ways. So when I convert between curved objects and regular objects, the manufacturing grid is used. So now we had been drawing objects like boxes and polygons and whatnot, but now Edit also has the notion of these other things called wires. And it's a little annoying because the representation of a wire is a little different than a box or a polygon, even though it looks like one. So there are special tools for drawing wires. They look like this. So on the drawing toolbox, if you want to draw a wire, you do it this way. You choose one of these tools. And then you indicate a width. So right now, the width of this wire is set to default. And I'll explain what that means in a little bit. So the wires can be orthogonal, 45, or all angle. And the wire width can be specified from the little drop down. And so I can set my wire width to a particular amount. And then when I go to draw my wires, I'm just going to indicate the center line, and Edit is going to calculate the sides of the wire for me based on the width. So you do a left mouse button to click and to draw the vertices of the wire. But instead of these vertices being like a polygon vertices, they're the location of the center of the wire. And then you use a right mouse button to end the wire. And if you use the middle mouse button, it will delete the previous vertex. So if you're going along, you make a mistake, you just hit middle mouse button and it will delete the previous vertex. So this is how you would draw a wire. So notice I'm not indicating like I would draw in Edit. I'm not indicating the edges of the wire, like here, I'm not doing click, click, click. I'm just indicating the locations of the center line. And I'm doing it with my left mouse button. And so then Edit will then just follow along, find these center points, take the width, and then extend extend the representation on either side of a center line that you drew. And so wires are defined by the width, the number of vertices, and the coordinates of the center line vertices. And that's different than how polygons are represented, right? And then how we end the wires are defined in the edit object dialog. And I'll show you that in a second, what I mean by wires. So if I have a wire that I just drew, then I can either edit it using the edit object dialog. And as you notice, the edit object dialog gives you something that's different than the polygon editing dialog or the box editing dialog. It gives you an actual wire editing dialog. So here you can set the width of that wire, you can add a vertex to your wire, and you can set the way that the end style is created. And so, or you can go ahead and just, click on your wire and just keep adding vertices. So you can edit it graphically, or you can edit it textually. As I said, you can modify the width, and then these are what are called the end styles. So if you have a wire, if you notice the center line here, this is the last click where I have my mouse, is the last click that the person made. And half of the width of the wire is actually added to that when it's displayed on your screen. So you actually add half of the width of the wire, where this style ends the wire exactly where you clicked. And then there are things called round wires, where Elidit actually adds a circle onto the end of your wire, okay? And so these are, different objects than Elidit would be drawing. You're like, why do I need another kind of object? Well, drawing wires is really fast. And like, for example, Priya had to do a lot of routing in your design. There were a lot of places where, things needed to be routed to the pads. So you can just draw wires really, really quickly. And so they're very useful. If you go to set up layers, okay, this is where we kind of looked at this yesterday, or no, sorry, not yesterday, this morning. It seems like yesterday. This morning, one of the things I showed you was the GDS numbers, right? So that can be set there, but you can also set the default wire settings, and that is where you do it. It's set up layers, and you can set the default end style, right? So you do it in the setup layers. So let's go look at that in the interface. So, okay, so here we go with our poly 1. And then this gives you a width, default width. And then where that shows up is when you go to make a wire with the wire tool. Where the heck is it? Is that the wire tool? Yeah. So let me select, did I do poly 1? I can't remember. Yeah, so here's, did I do that for poly 1 or for poly 0? I can't remember. Yeah, I don't know why it's not picking up the default. Maybe it's for here. Oh, I guess it just sets it to the default, and you're supposed to know what that is. Yeah. So this will set, this wire will then use the default settings when you start drawing it. Okay, so let's go take a look. Yeah, see the wire width is 0.2. That's because we set the default wire width to be 0.2. So now I'm going to go through a couple of useful macros for you that you may use in your next project, and then some of them that may be useful to you now. If you this built-in macro allows you to take a mask and resize it on a layer by layer basis. And why would you want to do that? Because some of the fabs, if you are, designing a polysilicon mask, for example, they may have to bloat or shrink your mask based on their equipment. Because of the precision with which their equipment can be operated. So they may ask you to change all the objects on your mask by a certain amount, either a negative or a positive. And so we call this mask biasing. And so this is a very useful feature. You probably won't need to do this for the JFET project because, Priya and the CMC are going to do any of that for you, or maybe they'll do it at 3IT. But just keep in mind, if someone ever asks you, hey, we need you to bias your mask, rather than you having to go in there and do it, ELEDIT has a nice macro for that. I won't go through the details of it now because we won't use this in the JFET design kit, but I have the slide here ready for you if you go back and say, oh, I got to do that. One of the things you may use in this project is ELEDIT has the capability of importing an image, because we always get asked about this, about logos, right? So the CMC has their logo that is on the reference design, but you may have your logo. And so ELEDIT is capable of importing an image and then creating a set of polygons from it. So you can, check that out under layout generators, import image, and it will merge all the polygons that it finds. And then it will, if you had a full color image, it will create it on one colored layer. And then, for example, here, this Mentor Graphics logo was converted to Poly 1, and it was translated into polygons. So the original image was a file that looked like this. It was a black little thing with a little watermark there, and it was converted in ELEDIT onto a polysilicon layer that then could be printed on the mask. So if you have a logo that you need to do, we often discourage this because you could create problems on your masks. Mask makers often don't like logos, but that's between you and your mask maker. The other thing that you can do is convert formatted text to layout. And you want to do this maybe for labeling your layout in some way. So you can type in some text and then it will be converted into layout objects. And that is different than, we'll talk about a second method for doing this. This actually takes true type fonts into polygons. So you actually specify a font, like for example, Calibri, and a text size, and it is going to then convert that to some layout objects. You probably also don't necessarily want to do that either, unless you want to write something fancy on your layout. You usually want to use a text generator. And the text generator is found under the draw menu as well. And here it's converting a text string into a set of polygons, but it's using letters from an alphabet that are already constructed as cells. So the text can be put in, letter by letter, or it can be placed as an instance. So I recommend, if you really want to do some labeling of your die, to use the text generator and not the true type fonts. This one, I would use this one because it's going to give you probably better results in the short term. And I always create it as an instance because then I can delete it when I do design rule checking. Okay, so let's start the DRC. Okay. All right. All right. So I guess I should ask though, is there anyone who does not want to use the DRC? I mean, do all people submitting designs to CMC typically do design rule checking, or are you encouraging that, or?
We usually encourage that they check on their end, but we also check on our end.
All right, well, let's teach it to them because then it'll be easier for you, right? All right, so we'll talk about design rules, how to review them, how to run the DRC, and how to review your DRC errors, and how to fix them. So we'll get started on this. And so what does the design rule checker do? It's checking the compatibility between layout and fabrication. So typically, the fabricator has, capabilities and limitations in their fab. And I noticed, like in the JFET design kit, you can't make metal smaller than 5 microns, whereas at TSMC, the metal, could be 0.18 microns or 6 nanometers or 7, 8 nanometers. So every fab has constraints on how your design has to meet these constraints in order to be fabricated by that fab. And there's an issue here is that we have what are called manufacturing rules that if you violate them, then the fab said, well, you violated the rule. So, I'm not going to guarantee that your design is going to work. But even if you obeyed all the rules, your design still might not work because it was a bad design. But it wasn't because it couldn't be manufactured. So we have to distinguish between geometrically, can the fab print or do that, can the mask be made, can the thing be etched, or they're not going to guarantee the function that it's going to act like a A to D converter, right? Even if it can be made. So design rules are geometric constraints on the layout. Design rules are geometric constraints in layouts limited by the fabrication capability. And so the design rule sets are usually provided by the foundries. In this case, CMC is giving them to you. And so to check a layout, you want to make sure you have your design rules defined, and then you run the design rule checker. And one of the things that is a problem or an issue in routing is all angle support, because there's some special things that happen that we'll talk about if you have all angle routing. And in the very first designs for the very first ICs, they did not allow you to do all angle routing. Okay, so why? I think anytime I touch the Zoom thing, it throws off PowerPoint. Let's see. Okay, so we are going to review some design rules, and we will. I will go ahead and show you. I have prepared for you some design rules that we'll use as an example, and we'll open those in a minute. But first, I want to give you the slides. The design rule checker is found under the tools menu. And so we have the capability of running the DRC on the entire layout, which is shown here. If you do DRC, it's here. Once it's started, you can stop it. Like if you had a very, very big design, it could take hours. In fact, some of the big guys, Intel or NVIDIA or God knows who, they can run a DRC for a week on a complicated design. It could chug for an entire week. So you need to be able to stop it. And they often do them in parallel on big computers. Then the DRC box command allows you to draw a box and then just execute the DRC on that box. And then you can set up the DRC or bring in the design rules. And you can also clear all the errors that you have in your design. Now, there's something else called an interactive DRC. And what is that? That is shown here underneath the regular DRC menu. And that allows you to run the DRC while you're drawing. Because most people draw all their layout and then they run the DRC afterwards. But you can also try to run the DRC as you're drawing. Most people find that annoying, but you can do it. And then here are the different icons. Okay, so here are the icons. I showed you the menus items, and here are the the different icons for that you can start the DRC from the toolbar as well. And there are different types of rules that can be checked. And in the CMC design kit, we don't use all of them, but I'll just run through them for you so that you have them, for your next fab. So the minimum width rule specifies that you have to have a minimum width of the polygon in all the objects in any direction on a layer. So it measures it, internally. So if this thing is at an all angle, that this arrow has to be of a certain width. The exact width rule specifies that it can't be a minimum. It has to be exactly that size. And contact cuts are often done this way. Because you could have some polygons that, as long as it's bigger than a certain amount, fine. But sometimes holes that get cut, if they're too big, they won't work. If they're too small, they won't work. So they have to be just right. So that's why some contact cuts are done with an exact width rule. In fact, we should talk about that, your via, whether your via should be exact or not. The not exist rule means that no objects should exist on that layer. And that just means that, it has no associated distance. It just means that these particular polygons should not exist on that layer. And we'll talk about tomorrow an example of that. The spacing rule sets the minimum distance between pairs of objects, and they can be either on the same layer or just different layers. And that rule is in the JFET design kit in multiple, between multiple layers. And then the surround rule specifies that the objects on one layer have to be completely surrounded by objects on another layer. And this is what we typically do for contacts surrounded by metal, that the metal typically has to completely surround the contact or it won't work. And then the overlap rule specifies that one object, the overlap rule specifies that the minimum amount that an object on one layer must overlap an object on another layer when there is an overlap. So for example, if the two objects don't overlap, then the rule doesn't count. But if the objects do overlap, then they have to overlap in a certain amount. So here the two objects are touching but not overlapping. Here it's overlapping enough, so it's good. Here it's completely inside, that's good too. And this is a violation because this one and that one, the red and the gray, are only overlapping by a certain amount. So that's considered a violation. The dual of the overlap rule is called the extension rule. And that does the opposite, that one object has to extend outside of the other object by a certain amount. And in that case, here, for example, this guy is poking out of this guy, but not enough. And here it's poking out just enough. And here they're not touching. And here they're completely enclosing. So we're good to go. And then there's also something called a density rule that it tests the percentage of area of a set of polygons covered by another set of polygons. And so, for example, this happens in the IC world all the time, is that if you have too much metal on your design, then you're in trouble. So you have to have the right amount of metal. So it figures out all the area of metal that you have, and then it will tell you that you have 30% of your design is metal. That's okay. Or 15% or 95%. And it will then flag that as an error if the density is not correct. And then there's also things that we do that we can ignore certain problems that may occur. One of the problems that you may have, and I don't know if this is a problem at the IIT, is that if you have 45-degree acute angles, some fabs do not like that. So the rule could be correct. You know, you could have a minimum width that's correct, but the objects you know, make a 45-degree angle when they come together. So that could be a problem. You also might have in spacing rules, you might have a, you know, you might ignore if the layer 1 is completely outside layer 2. Things can happen when they're coincident or if they intersect. So you can specify the types of things that we're going to ignore on a given rule, on a rule by rule basis. Okay, so how do we set up the design rules? You are not going to have to set up any rules in this class because the CMC has made them for you. But you will get to see, you know, you'll get to see what the rules are that the CMC is going to check and make sure that you don't violate them when you draw stuff. So if you go into the DRC setup, or you can go on this little icon here, the setup DRC window appears. And then you get this window that comes up. And this allows you to specify the different rule sets that you're going to run. And when you link to the design kit, like we're going to do tomorrow and what we did earlier today, the design rule sets are going to be already preset up for you. And Tanner allows you to run rule sets that come from Tanner or from Caliber, which is another DRC tool. I think you guys have access to that at the CMC, right? Oh.
Yes.
Okay. And then also Cadence, right?
Yeah.
Okay. So anyway, in this class, we're going to use DRC setups that come from Tanner. And then by default, only the Tanner rule sets are listed. And typically, you know, we cover all the different design rule checkers in the advanced class, but in this class, we are just going to talk about the Tanner ones. And then also on this screen, we specify if you had multiple rule sets, you could decide which one you wanted to run. So for example, if I had some MEMS rules and IC rules, I could say, okay, I want to run the MEMS rules, or no, I want to run the IC rules, or both, or whatever. And then you can specify what happens with your design rules. You know, when the DRC completes, it can send you an email, it can play a sound, it can pop up a message box. So there's a bunch of stuff that you can specify about how to run the DRCs. And we do that because DRC takes a long time to run. So typically you're going to walk away from your computer and you might even be checking your email just to see when your DRC job completes. Now, these designs that I've seen so far for the JFET are pretty simple. So I don't think the design rule checker is going to take very long to run. Okay. So here we're going to now take a look at the design rules. And so the way you do that is you click on the little pencil thing. And that is going to allow us to open the actual DRC rules themselves. But you can also add these little buttons here on the right. You can add a rule set, you can delete a rule set, and you can move them up and down in the list. And the reason why there's a list is it's going to run them in the order in which they're checked and on the list. Okay, so the other thing that we'll talk about is how the rules, what do they look like in the design rule checker. So we have a rule set name. We also have what's called an all angle tolerance. And this is going to be important for your JFET design kit because I saw a lot of all angle routing in there. So as we talked about, if you have things that are at all angles, as I told you, LEdit is on a grid. So LEdit snaps all of your polygons to a grid before the DRC is executed. And that includes, circles and everything. So when it snaps it to the manufacturing grid, it might change the size of your wire. For example, if your wire was once exactly 5 microns, it might be 4.98 now because L-Edit snapped it to a grid point that is not, going to cause that width to be the same. So that's really important. And so if I drew on a grid, when I snapped a grid, all my objects are the same size. But if I drew an all angle wire and it's not on the grid, I could easily get a DRC distance that is not correct and it is, miscalculated. Or I could have just made a mistake. So the problem is, how do I tell the difference between something that I drew that was not really was not 5 microns wide, and I'm just drawing it on an angle, and so L-Edit moved it for me, versus something where I screwed up and I didn't make it wide enough. So this is why when we apply a tolerance to the design rules, we really have to think about it. And we saw this with Priya yesterday, that sometimes if you have an all angle check, you get all these false errors because your design is fine and L-Edit just moved your points. And so it's flagging a bunch of things that really are not wrong. Or you could have, by mistake, made a misalignment of a cell, of an instance of a polygon, and that you just screwed up, and it just isn't, it just isn't aligned where it's supposed to be, and it's a real error. So the tolerance function gets applied to the design rule. So for example, if your rule is 5 microns and the DRC finds 4.98, it will apply the tolerance to your result and then ignore it if it's within the tolerance. But as I said, use that very carefully because you could have screwed up. Well, what happens if you do screw up? Is really 4.98 so bad? Probably not. So using a tolerance normally isn't so bad. And so I think in the case of the DRC for the CMC, they have to have that discussion with the 3IT, and if the 3IT says, oh, sure, why not? Then, put a tolerance on there, because your all angle rules will be, won't be constantly being flagged. But on the other hand, they really need to know what the tolerance of the rule is, right? And so that's a conversation between the PDK maker and the fab. And they have to figure out whether that tolerance is okay or not. But for those people who are designing on an all angle, this issue will come up. Okay. And then when you go to run your design rule check, rules that have a check next to them will be executed. And if you want to skip a rule, you can uncheck it. So for example, when I'm designing my pads, I don't want to be bothered by a bunch of rules that, I'm not thinking about right now. So I can turn some of the rules off and run them, and then turn them on when I'm finished my design. Okay. And so this enables you to customize based on the rules that you get from the CMC, which one of those rules you're going to run right now. And most people do partial design, like they'll design, some layers, and then they want to run a DRC check and see how it's going. And so they'll turn some of the layers that they haven't drawn yet, they'll turn them off, and they'll run the DRC. And then when a design rule is clicked on, it's going to then show the rule name that the rule name appears on the right hand side, and then all the information about that rule is displayed. And so as you click on the rules, it will then show you, for example, the name of the rule here, A-line spacing, It will show you what type of rule. Remember, we had 8 types of rules. The rule distance here, in our case, our technology units are microns. And then it's going to set the layers that are involved in the rule. And you can set those layers using the drop downs in ELEDIT. So basically, for the JFET design kit, you are not going to have to set up these rules, but you should look at them and make sure they make sense to you when you're drawing. So we will be, tomorrow in the class, we'll be pulling in the design rules for the JFET design kit. We'll be looking at them, but we won't have to set them up ourselves because Priya and the team from CMC set them up for us, and they did it correctly. So all we have to do is run the design rule checker. So we will then, once we're done looking at the rules, we would then, click OK and close the technology file. And that's what we're going to do tomorrow. We will look at the, we'll look at all the technology rules, and then we'll close the technology file and we'll open our design and use them. So I have a few minutes here. So I will take the next 5 minutes just to show you in slides, what it was like to run the design rule checker. And then we will make you have access to the example so that you can run it yourself, because we actually have a worked out example that you can run. So normally we would run this RF switch design. Then we would import the technology that we just looked at and click OK. So, we would import it. Remember, we could pull up that import technology and pull in those design rules. We'd take a look at them, make sure we understood them, and, that they came in okay. And then you run the design rule check. You would go ahead and click on the DRC or use the little icon that we had. And then the DRC progress window will come up, and it will tell you what it's doing and how many seconds it's taking, and what phase it's in. And then when it's done, it gives you the verification browser so that you can find all your errors. So in this case, in our design, the person designing the switch made 2 errors. It's going to flag anytime we have the polygons with acute angles, but maybe that's okay. It also tells us that we have some all angle edges. That's probably okay too. But here, these are real rules that are violated. So it's saying that the spacing, this line spacing is less than 18 microns when it should have been 18. And then this contact over line overlap rule is less than 30. So it found some of those violations. So then if you want to, you can change whether here it's giving you a listing of rules, but you can also have it change so that you can view it by what kinds of errors are in each cell that you made. I always just find my errors by error. I like to find all my spacing rules and then all my other rules. And so I usually just keep the interface like this. And then what you can do is that once you have your rule list here, you can see there it's got little pluses. You can expand the little pluses and actually find the real errors. So in this one, we have a contact over line is less than 30. And so error number 1 says, hey, here it measured 27. And in error number 2, it also measured 27. So this person made a mistake. And when you double click on the error, ELEDIT will pan and zoom and place a marker right where the error is. That's called the DRC browser. And so ELEDIT will then, every error that you click on, it will go show you where it is. And here it's got these 2 black marks here to show that there's only 27 microns, and the rule should have been 30. And so this makes it easy for you to fix your design rules because Edit will find them on the layout and tell you what you did wrong, and then you have to fix it, right? And so, you know, here we are both, you know, we are needing to go fix this rule. Okay, so I think I'm just about on time. Yeah, so tomorrow, what are we going to talk about? Well, we're going to talk about the design kit from CMC for the JFETs. And by using that design kit, you'll get a review. You know, maybe you're not going to use that JFET process, but you may want to sit in just because you can get some more practice and training on, you know, some of the concepts that we talked about. So we pretty much got through everything I wanted to show you, especially with this, you know, we got through the DRC. So, you know, tomorrow we will use these concepts for, you know, talking about the JFET design kit, and we'll also have time to do more exercises. For example, you'll run the DRC. You guys will run the DRC tomorrow instead of just listening to me about it, because normally in the class, the next thing we would do is have you have an exercise about it. But since we had so many good questions, we didn't quite get that far. So, you know, up to you whether you want to attend tomorrow, or as we said, Priya would, you know, a lot of this information will be available to you on the web.
Okay, so whoever is not joining tomorrow, thank you so much for coming in today, and for others, see you tomorrow.